Hello grade 12s, welcome to my channel. Let us have a look at this question paper. It was by request, so I do hope that the person who requested this review is going to be watching and perhaps will find the answers they were looking for. And those who are fanatics alongside me, let's enjoy it. So this is from November 2012. So instructions, guys, very important. We need to read all instructions carefully, taking care to adhere to them whenever there is nothing else better. But of course, we need to put these into mind and make sure we remember them throughout the exam, especially for a specific paper. And of course, anything that is acceptable can be used to determine answers. And if that's the case, we need to show it. And of course, the issue of rounding off, this one says 2 decimal places, no more, no less. And of course, we read the rest and we ensure that we have them covered as we answer. Okay, let's have a look at this question 1. Of course, I call this part the warm-up exercise before the actual exam. But sometimes there is a bit of an exam within this question. Usually 1.3 tends to be that kind of a question. So we're solving for x. So 1.1 with 1.1.1. So we are given 2x minus 1 into x plus 4 equal to 0. Now we know here that we can just go for the answer. We know that x is a half, or x is going to be minus 4. Simple and straightforward. This is grade 10 stuff. So of course, guys, we check if we did not make a mistake by plugging these solutions back into the original and see if the left hand side equals the right hand side. When we put a half in there, we get a 1. 1 minus 1 is 0. 0 multiplied by anything is going to be 0. This means 0 is equal to 0. Our left hand side balances the right hand side. We put a minus 4 in there. We get 0. 0 multiplied by anything is going to be 0. So 0 is still equal to 0. So that solution also holds. Please run a check, guys. Do not assume you've got it right. All right, so 1.1.2. We have 3x squared minus x is equal to 5. And we are to solve correct to 2 decimal places. This is already a suggestion that our roots here are irrational. And actually rounding off is what essentially rationalizes the denominator here. Or we're rationalizing those solutions. Now, this quadratic is not in standard form. So this demands that we put it in standard form first. So we have 3x squared minus x, we transpose the 5. Once 0 is on the other side, this is the standard form. And of course, if you did not get that instruction, you can just check the discriminant quickly. If it is not a perfect square, it means you don't need to waste time trying to factorize. Okay, so we go straight to the quadratic formula. X is going to be minus b plus or minus b squared minus 4ac. Right, all over 2a. We substitute. So this is the key step in using the formula. So this is minus into minus 1, plus or minus the square root of minus 1 all squared minus 4 into 3 into minus 5 all divided by 2 into 3. Of course, some teachers may force you guys into trying to simplify this. Otherwise, for me, it is an absolute waste of time. Doing it and not doing it doesn't make any difference. But again, do what you are told, and your teacher is the main guy. I am just a distant loud mouth, I guess. Yep. So be very careful not to adhere to my preferences, but to those of your teacher, because that person is the one that can assist you closely or not at all. So this is going to be 4, 7 to 2 decimal places, or x is that becomes minus 1,14 to 2 decimal places. So that is our answer. So again, guys, we need to check the solutions in the original, provided it is copied correctly. As we can see, this is a whole number. So we are going to have to solve correct to the nearest whole number, the left-hand side. So let's see, we've got 3 into 1,47 squared minus into 1,47. So rounded off to the nearest integer or whole number. This is good. I get 5. Let's try the second one. You see, miracles have already, coincidences have occurred in the past, and they can still occur. So do not take anything for granted, guys. These are marks that can decide your fate in life, So don't be careless. Again, this rounded off to the nearest integer, that comes out tops. Okay, 5 is equal to 5 in the original equation. So this suggests that our substitutions are correct. And usually this should be a 3-mark question. We don't get a mark for the formula. But the only way this part scores a mark is when the formula is itself correct. If the formula is incorrect, the substitutions become incorrect automatically, even if they follow what you wrote in the formula. But the formula being right or wrong is not an issue. What is an issue is the actual correct substitutions, and they only get a mark if the formula is correct. And remember, the main instruction said we need to show everything we have used. That means even if we use the formula, we need to show the formula. We can't just show up with substitutions. I do believe the extra marks should go for the standard format of our quadratic, okay? Because that's very important before we can use the formula. So that's how we score those 4 marks, I believe. So let's move on. So we have 1.1.3. So we have x squared plus 7x minus 8 is less than 0. We can factorize this. So this is x. Those of 8, which can give us 7, is going to be plus 8 and minus 1. And maybe let's just use the graphical method here. not waste our time. So this is our graph. It's a smiling face parabola, and the axis of symmetry is this side. Right. So that's what we've got. And this is going to be -8. That's 1. That's a -8. Okay. Nice and easy. Always try to do a near perfect sketch. So when is our graph less than 0? As in below the x-axis. So we can see that all this part of the graph below the x-axis is what is essentially less than 0. So this means this is between the two critical values. So we can write here that x must be less than 1, greater than -8, where x is an element of real numbers. Although, guys, the inequality itself is suggestive of x being an element of real numbers, but be in the habit of writing it, especially when it comes to situations where we can apply this when x or any variable in question is not in the set of real numbers, but a specific portion of the real number system. So it becomes a bit of a situation, okay? So be very mindful of this. So normally this is 2 marks. How many marks are we scoring here? 4, okay? Perhaps the sketch would get a mark because that's the method we have used. And whenever we factorize, that's very important. But another person may think of the extra mark going for specifying the set in which x belongs. But in this case, the inequality covers that nicely, so it's not so much of a big deal. But I'm making it a big deal to suggest to a student that this must be known and understood, okay? Otherwise, if that is missed, problems will always occur, okay? Great, so let's look at 1.2. 1.2, we've got those equations, and we've got 1.2.1. We are to solve simultaneously. So what is important? To take the linear equation first, and we can just isolate x here. This is going to be equal to 4y minus 4. Make this equation 1. We have been given the hyperbola xy is equal to 8. So this becomes our equation 2. So all we do, we just put 1 into 2. So where we see x, we put 4y minus 4 times y. This is going to be 8. This implies that 4y squared minus 4y minus 8 is 0. Okay, so we can divide by 4 throughout. So we get y squared minus y minus 2 is equal to 0, which implies that we get y minus 2 plus 1. Therefore, y is minus 1, or y is 2. And of course, we substitute these into the first equation. X becomes 4 into minus 1 minus 4, or x is going to be 4 into 2 minus 4. So this tells us that we've got minus 8. Here we will have just 4. Great. So we've got our solutions. Now what we need to make sure of is to check a pair of these solutions, x and y, into the original, provided it is copied correctly. But any of the original ones, including equation 2, can be used for this. For example, equation 2 becomes much more easier because if you take -1 for x and -8, that product becomes 8. So 8 is equal to 8. Or we put it over there, we get -4 plus 8, which becomes 4. So 4 is equal to 4. So this means this pair is good. And then we take the next pair and check it out again. So if we use equation 2, for example, which is much simpler as well, 2 times 4, that's 8. So 8 is equal to 8, so that's good. Or we put it into that equation. We will have 8 minus 4, which is 4. So 4 is equal to 4. Right. So that's what we have. So this means our solutions are good. And of course the method of substitution is what is good. So usually this is 5 marks, but we're getting 6. So perhaps for making x the subject in there. Otherwise, this is a very simple question, but very important. Excuse me, in maths throughout. So do not forget simultaneous equations. So 1.1.2. This is 2, by the way. Aye, man, what am I doing? Damn it, man. Damn it, man. Damn it, man. Yeah. So, you see, guys, very important to make sure everything is labeled correctly. So the graph of 4y minus x equals 4 is reflected across the line having the equation. So this means we are dealing with an inverse. Okay? What is the equation of the reflected line? Okay, so what is the equation? Okay, meaning that, so basically we just swap x and y. Easy. Answer only. 2 marks is good enough. So this means it's going to be 4x minus y equals 4. So for this one, we get marks for switching the two, I guess, or just the entire thing. Say perhaps the switching and the overall equation, it really is not a big deal. So let's get to 1.3. 1.3 says the solutions of a quadratic equation are given by x equals -2 plus or minus the square root of 2p plus 5, all divided by 7. So the question is, for which value or values of p will this equation have 2 equal solutions? So this means equal roots. So we're dealing with nature of roots here. So this is 1.3.1. We know that here for equal roots, it is such that the discriminant must be equal to 0. Now this implies the discriminant in our expression is basically what is under the square root sign. So we write it as it is, 2p plus 5 equal to 0. Therefore, when we solve for p is going to be -5/2. If you chose to write this in decimal form, this must be -2,50. take care to add that extra digit, because the general instruction was clear. 2 decimal places or nothing. Right? Right. So this is the case. If you write 2.5, that answer becomes incorrect, and unfortunately you're going to be marked incorrect. So do not lose marks because of craziness. So that's substitution and the answer, whichever you decided to show, make sure it is in the correct format. All right, so 1.3.2 says we don't want any real solutions, meaning our graph doesn't touch the x-axis. All right, so this is good. So what we're going to do now, if I can tell you, what would be the shape of this graph on the Cartesian plane? If I were to just poke you a bit, what do you guys think? What do you think we should have? Will the graph be facing up or down? Now remember guys, you need to always be critical in thought and very strategic. Right, so this would be the origin. Now obviously if I tell you this graph is supposed to be stuff like that, what would you say? Would you say I'm correct or incorrect? What would you have on your side? Why do I know this is the case? Well, the reason I know, I looked at my denominator. Remember, that denominator is dominated by the sign of A. For it to be positive, it means A was also positive. And in a quadratic, when A is greater than 0, what happens? The graph is concave up. Right, so I hope guys we are clear. Can you see? There's a lot you can do if you just understand what's going on. Okay? Very, 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 very important stuff here. So of course, if I was to ask again another question, what is the likely value of A? Most likely 1, because for that 7 to be a 7 and we multiply it by 2, it's most likely 1. Right? Right. But again, it could have been a fraction, you know, a 3,5 of some sort. When you multiply that by 2, it can give us 7. So the most likely though could be 1, an integer. That would be, of course, if we are told A is an integer, or it's a whole number. But if we are told A is a rational number, then we can choose the smallest fraction. That would give us a 3.5. So again, guys, think about these things, because these are some of the challenges that many of you cannot navigate during an exam, because you are always narrow in your approach, and that's what always drops you. So some very easy questions can really cause you trouble. So for no solutions, this is what we expect to see. And of course, the reason I know that that graph is concave up, it's looking at that denominator. This tells us that A is certainly greater than 0, because A is the only determinant of the sign of the denominator there than any other coefficients. Remember, it's 2A. So 2 is already positive. It's never negative. But the A can be negative or positive. So if the answer or the result thereof is just positive, then that's good, because we can see nothing is manipulated here. But if this was a different scenario, where this one divided this, that would be something else. But again, it would not be possible to just do that and this alone. but sometimes you get surprises. Hey, be very careful. Anyway, just be in the habit of just enjoying what you have and understanding it so well. So we know that for non-real roots, it is such that the discriminant must be less than 0. This implies that 2p plus 5 must be less than 0. Therefore, p must be less than minus 5 over 2. Alright, and again, you can choose to write this in decimal form, but if you do, make sure you add that extra 0 to make it 2 decimal places, or else you're going to lose that last mark. And in this case, this is the only mark. So if your answer is not correct, or it's not given in the correct manner, and you lose that mark, students, even with the correct answer, technically speaking, or should we say in actual facts, you are correct, but technically you're not adhering to the instruction, because this is not just any general mathematics class at this moment. This is an exam in a particular country for a particular period, so we can choose the conditions that should befit that exam. And if you don't adhere to those, you are kicked out, right? Otherwise, folks, this must have been a very easy 21 marks in total to score. So those who wrote this exam literally cruised, because this was mainly grade 11 work. Nothing really from grade 12 here. So let's charge to question 2. Now question 2.1, we are given 3x plus 1 going to 2x going to 3x minus 7 are the first 3 terms of an arithmetic sequence. We need to find the value of x. So the fact that the signature of that sequence is given to us, we know that in an arithmetic progression, there is a common difference between any 2 consecutive terms, right? That's the definition of an arithmetic sequence. So we know that if this is AP, this implies that basically 2x minus 3x plus 1 should be equal to 3x minus 7, minus 2x. We know that each difference is equal to d, right? Excuse me, guys. I don't know, when I start talking lately, this throat of mine just does its own things. Maybe we may not say this implies, but we can just write that as a rule. So we get 2x minus 3x minus 1 equals, this one is going to be just x minus 7. So what are we going to have? This implies, now this is going to be minus x, this is minus 2x, equals minus 7 plus 1, that's minus 6. Therefore, x is going to be 3. And of course, we were told this is an arithmetic sequence. So we can substitute 3 for x and find out what sequence that is. If it shows up as an arithmetic, we don't care about the value. It should be correct. But if when we substitute 3 there, we don't get an arithmetic sequence, then it means our value of 3 is incorrect. So the guide here is to then substitute here the value of x and check that that sequence is truly an arithmetic sequence. And if that's the case, you may want to accept the value of x, even if there's a mistake, but it doesn't give the vibes otherwise. All right, so this is easy. What we need is the rule and the answer. So that's what we need to handle there. No biggie. So we've got 2.2. We're told here that the first and second terms of an arithmetic sequence are 10 and 6 respectively. So we've again got an arithmetic progression, which is 10, 6, and then it continues. And if you look above, actually, when we substitute 3 there, what do we get? 10. When we substitute 3 there, we get 6. So this is technically the same sequence that we have above. So if you've checked, you already are being given a clue below that this value is definitely 3. So this is a confirmation in a way, you know. Very interesting stuff. But again, I've been telling you guys that in any exam you write, there's always clues around every question. Whether this comes before that question, within that question, or after that question, however distant it may be, there's always clues. Of course, not, okay, let me not say there's mostly clues. Okay, maybe that's the best way to put it. Always makes it look like in every exam you'll find that. No, it's not the case. But in most exams, that's the case. Right, so we need to calculate the 11th term. So we know that t sub n is a plus n minus 1 times d. So this means t sub 11 is going to be 10 plus 11 minus 1. D is going to be 6 minus 10. Okay, we can do it here. We can do it separately. It's not that much of a big deal. So this is going to be 10. 10 times minus 4, that's minus 40. Minus 40 plus 10 is going to be minus 30. Either way, one can put this in the calculator. So the key step here is mainly the substitution into a correct formula. But within these substitutions, this is the main substitution, to be honest, because it wasn't given. We chose to do it within the calculation. Another student could have done this separately and then plug it there. So it doesn't really matter. And of course, the final answer mostly gets a mark. Okay. Easy 2 marks. 2.2.2. We then are asked the sum of the first, in fact we are told, the sum of the first n terms of this sequence is minus 560. We now need to find the value of n. Since this is arithmetic, so we know that s sub n is going to be n over 2 into 2a plus n minus 1 times d. So this implies that minus 560 equals n over 2 into 2 times 10 plus n minus 1 times minus 4. Great. So we simplify. Minus 560 is n over 2. Now this becomes 20 plus 4, it's 24. Then this becomes minus 4n. Okay. Then we simplify further. Minus 560 equals, when we multiply that n over 2 to 24, we get 12n. Minus, we multiply there, we get 2n squared. Now we can see we've got ourselves a nice quadratic. So this is 2n squared minus 12n minus 560 equal to 0. can divide by 2, we get n squared minus 6 n minus 560 divided by 2. What is it? 56 is basically 28, right? 56 divided by 2 is 28, and then we drop the 0. That should be 280 equal to 0. Let me just double check. Of course, there are some shortcuts, folks, but be very careful. Yeah, it's 280. So be very careful. Sometimes they're not so good. Sometimes they're so good. You have to literally experiment with these for one to be comfortable. Now 280, we don't know. We can break it up by writing this onto the calculator. And after that, we press the shift button and then we fact this thing. So let's see, 280 equal, then shift, fact. It gives us 2 cubed times 5 times 7. So what do we have here? This one is going to give us big numbers. We may need to split the 2, say maybe 2 squared times 2 times 5 times 7. Now we can see that if we group 2 squared and 5, we get 20. And when we take this and 7, we get essentially, this is 20 times 14. And we know that 20 minus 14 is 6. So basically this means this is minus 20 plus 14. So please guys, know how to use your calculators when that is convenient. While practicing, of course, try to crack your skull a little bit. So therefore we know that n here is going to be equal to 20 because we know n is an element of natural numbers. All right, so we are rejecting the negative integers because remember, natural numbers are positive integers. 0 is not positive, nor is negative, so we don't include 0, at least for the metric curriculum. All right, so let's have a look. What do we have here? 6 marks. Okay, you can say this is a mark. The skill of factorization almost always gets a mark. Well, we can call this simplification or whatever, because there's lots of marks on offer here. And then we can say substitutions. So that's the 4 marks. In my opinion, this should be 4 marks. But yeah, we can say substitutions on the left, on the right, maybe, to try and drive this to that. So what is the extra mark? Perhaps stating, maybe stating the set in which n belongs is key, because these 6 marks are suggesting that we need to do more than just get the value of n in its literal sense. We probably have to kick into some algebraic modes as well to say, look, the reason we are rejecting minus 14 is because n is an element of natural numbers. So that becomes important. Or another student may write n is not equal to minus 14 and n is equal to 20. For rejecting the minus 14, one is already suggesting something, that n cannot be a negative integer. Nice and easy. So this is essentially how I believe these marks are to be given. So you see, sometimes the mark allocation, please guys, don't just look at it carelessly and say, whatever I did is going to give me marks. Remember, this is an exam of whether you understand the subject or not. It's not an exam of whether you are capable of performing the mathematical gymnastics here. Yes, you may be looked in that you may be looked at in that light, but we are actually looking more than that, because we know if you sit for this exam, you are definitely capable of performing some mathematical gymnastics, especially the common ones. In fact, you hardly do more than the 3-step approach, right? So, but some questions, the mark allocation is also suggestive of, okay, all right, I'm probably supposed to do more than just, the simple standard approach here, because the examiners cannot tell you, cleanly what exactly they want. They have to hide what they want, but it has to be transmitted somehow. So I do hope that these reviews, guys, are going to assist you to really master your work to a point of, you even know where the marks sit as you write the exam. At least gauge. You will get the hang of this, folks. Of course, don't spend too much time into this, but do consider it, because many of you miss the distinctions or those good marks because of these small little things that not even your teachers emphasize, because they think teaching is all about just standards. Of course, standards come before whatever is not standard. Okay. Anyway, those were the easy 10 marks, I believe. So let's get to question 3. Question 3, we are given a geometric sequence. Wow, these ones were just giving you guys homework in the exam, or classwork in the exam. So we've got a geometric progression, 27, 9, 3, and we can see this one is a convergent geometric sequence because R is a proper fraction here. So 3.1.1 says determine the Tn formula. Maybe let's start a bit lower, because there's going to be exponents. So T sub n here is ARn to the minus 1. So therefore Tn is going to be A27. R is what we need to determine. It's a third, right? To the n minus 1. So another student may want to simplify this further. It's up to you, truly. There's no point. In fact, there's no need. You can make it as as complicated as you want, but the reality is that let the examiners push you in that direction rather than you push yourself around. At times they may manipulate this and say prove that the Tn formula or the nth term is this. Then you can push yourself accordingly, of course. Don't just stray away. Great, guys. So the main issue here is finding R and writing the nth term properly or safely. Right, easy class work type questions. I hate these in the exam, honestly. Why does the sum to infinity for this sequence exist? Because R is less than 1, greater than minus 1. In fact, we can say here, we can write this, or we can say a third is this, because a third is basically R. So you either write R or you write the third, stuff like that. So you may want to be very clear and write a third, because that's R, so that is Y. 1 mark in the bag. So 3.1.3. We now need to find the sum to infinity. It's going to be A divided by 1 minus R. A is 27 divided by 1 minus a third. So therefore our sum to infinity. Now we know we multiply this, 4 minus 1, that's 3. Wait, 3 minus, that's going to be 2 over 3. Right. When we divide by a fraction, the 3 multiplies 27, it becomes 81 over 2. Of course, another student may decide to write this as 40,50. Remember, it's 40,5 realistically, but because of the requirement by the instruction, we need to add that extra digit. So if you're going to show that answer in a decimal form, make sure it's within the acceptable decimal form for this particular paper, not in your head, okay? Not in your head. So substitutions, answer whichever you decided you're going to give, but make sure the answer is given correctly. Right, so 3.2. Do we still have space? Okay. Now 3.2 says 20 water tanks are decreasing in size in such a way that the volume of each tank is half the volume of the previous tank. The first tank is empty, but the other 19 tanks are full of water. So it says, would it be possible for the first water tank to hold all the water from the other 19 tanks? Motivate your answer. Can you see? Nobody says how you're gonna do this. Remember we said, etc. We can motivate however we choose. So if we say let the volume of the first tank be equal to x, right? If this is the volume, this is going to be the volume of the next one. This one is going to be the volume, and 8th is going to be the volume, and then the 16th is going to be the volume, right? Please guys, basic things must not be an issue here. So it says now then the sequence of, or maybe since this is a series, then the series of 19 tanks is going to be such that we've got half x plus a quarter of x plus an eighth of x, and then it goes on. Of course, we know that we have a particular number, so usually with sequences and series we just need, these things. And of course we know r here is a half, so we can say, well, the sum of 19 terms, okay, maybe let's start here and say S sub n is a into, since our r is a proper fraction, it's going to be 1 minus r to the n, all divided by 1 minus r. So we can say this implies that S sub 19 is going to be so this one is basically a half. In fact, to avoid too many fractions, I'm going to write 0,5x into 1 minus 0,5 to the 19, all divided by 1 minus 0,5. You can say therefore the sum of the 19 terms here, meaning all the water, the volume of the water, So 0, in fact, let's do this, 0, 5. We'll ignore the x this time around because it's just going to multiply the final answer into 1 minus 0, 5 to the 19. All of this divided by 1 minus 0, 5. So this gives us a 0,9999. You know, when you do this to 2 decimal places, we literally get x. Okay, we just get x. And so can you see that the sum of the 19 other tanks, the volume of water goes back to the volume of the first tank. So you can say, therefore, the first tank will be able to hold all the water from the other 19 tanks. All right, so that's it. Of course, guys, nobody can tell you the specific way you're going to answer this, but try to be as clear as possible. I would mark this as a higher grade question, or perhaps slightly higher than standard grade. But again, it's what you would call a class test, not an exam, national exam. But hey, it is what it is. So, okay, this question is not bad. If you know how to plan, you know what to do. Or mpashash. So we're scoring 4 marks, of course, knowing that R is a half, good, and the general substitutions, and the answer, and the conclusion. So that should give us the 4 marks. Nice and easy. So let's get to 3.3. 3.3 says the nth term of a sequence is given by, can you see, this is a quadratic sequence, but this quadratic nth term is given in the turning point format, or the so-called vertex format. I always say, guys, sequences and series must be thought of as algebra, or applications of algebra, including functions, because each one represents a particular function on the Cartesian plane. So all the characteristics kick in. So we know that, okay, Tn is minus 2 into n minus 5 all squared plus 18. Great. So we know that this is a grumpy face parabola, first and foremost. The axis of symmetry is on the positive, right? Because we know that it's going to be given by n minus 5 equal to 0, which means n is 5. But then the y-intercept is going to be the interplay of this squared plus the 18. So this, in fact, this squared times the minus 2 plus 18. So let's find out what that is. So this is going to be plus 25. This is going to be minus 50. Minus 50 plus 18 is going to give us minus 32. So we can clearly see that our y-intercept is stuff like this. So probably that's the graph we have. Containing afuna ukwenza le nto ngoyenza wena man. Hayibo. Ayifoni ifuna undihlanyisa. Chechela kwana he nganiso. Uwayibona. Yes, it's like this, it's like that. Now remember, this one is the n-axis. That's the origin, that becomes the Tn-axis. And we know that at the maximum, we've got 5. And the corresponding y value is going to be 18, right? Those are the coordinates of the turning point. So guys, please, what I'm suggesting here is golden. Make sure you don't miss it. But again, folks, it depends on the first term here. As you can see, the first term will be negative. So the graph below the first term, if we assume this is the first term right here, if we assume that that's T1, then it means our graph below that part does not actually exist, meaning the y-intercept of minus 32 also does not exist. So these are some of the things or some restrictions that we need to consider as we work through these problems. I'm just stretching this because you never know when it's going to become what you need to keep in mind. As you saw in the matron exams, I always spoke about this and it came. And some students were like, what? So be not surprised. Think of these things as functions as well as algebra. Anyway, let's start answering. 3.3.1 says, write down the first three terms of the sequence. That's easy. So we know that this is the quadratic sequence. First term, we put a 1 in there, we get a minus 4. That's 16. That's minus 32 plus 18. That's just minus 18. Can you see it's negative and our graph didn't lie? Nah. Of course, you can just put it as it is and see what you get. Hey, I'm getting minus 14. 10 will total minus 14. Oh, that was 32. Not 36. Yes. You see, the mind games are not gelling here. So sometimes bilayela helps a bit. Let's just continue this way. So the second term is going to be 2 minus 5 all squared plus 18. So that one is noto, because that would be, that would be 9 minus 18 plus 18 is 0. Okay, good. And then, second one, I think I get done. Okay, now that's correct. Okay, 0. The third one is going to be 2 squared, which is 4. This is minus 4 plus 18. That gives us 14 again. Okay, let's see. Yo. Hayibo. Imathi yami itheni uyanhlanyisa. Wayenhlanyisa manje. That is 8, man. Yare doch. Hayibo. Susebenza ingqondo kanje labafethu. Yo. Uzosibosha wena but hayi masivele siyeke nje nokuzibonakalisa basidom kangakanani. Rijamaqanda jwala. All right. Yeah, we're scoring eggs. 0 qanda qox. Anyway, guys, so the question is on these. No issues about it. However you present these. So 3.3.2 says, which term of the sequence will have the greatest value? As we know, it's going to be term 5. So it's term 5. Just right. It's 1 mark. No questions about it. Nice. So 3.3.2. Can you see, guys? I was right. This was just huiswerk, man. Or klaswerk. So I don't see why this thing is in the exam. What is the second difference of this quadratic sequence? Remember, this one is 2a. So now what is the a value here? The a value is that 1, so we just double this thing. It's gonna be minus 4. Of course, when the question says what, we can answer only, or we can show how we arrived at the answer, but an answer only is good enough. So remember, the second difference here in a quadratic, it's 2a, and here we have the a value, which is minus 2. So we double this, we get our things. Or one can work with this the standard way, say 0 minus 14. It's going to be just 14, and say 10 minus 0, that's 10. Then 10 minus 14 is minus 4. It still comes out. Okay, so 3.3.4 says determine all values of n for which the terms of the sequence will be less than this thing. So here we are saying t sub n must be less than minus 110. So this implies that minus 2 and minus 5 all squared plus 18 must be less than 110. So what we're going to do here, we will expand here. This is going to be n squared minus 10n plus 25 plus 18 plus 110 should be less than 0. Moving everything, so we get minus 2n squared plus 20n minus 50 plus 128, right? Less than 0, which also implies that these numbers can divide 2, so this implies that n squared minus 10n, this is going to be minus 25 plus no. Mark, let's first deal with that value. It's 78, right? Then we divide that by 2, it's 39. So this becomes minus 39. Less than 0. Are we good? Yes, we should be. So we can factorize this thing, because now we have ourselves a quadratic inequality. So 39 is it 13 by 3? Let's see. 13 by 3, yeah, 39. So this should be minus 13. This is plus 3. Right. So remember, this is an inequality. We can use our graphical method to handle business. And of course, we should bear in mind that with this one, n is an element of natural numbers. So there are restrictions here. Okay. So of course, this graph is based on this step, right? Because that's what we factorized. So be very careful. Now this one is telling you and I we get minus 3 and 13. So this is the graph that we get. Okay. So, and of course, this is the TN axis. origin. There's no x. I'm so used to x. So that's the case here, guys. Now, what we see, of course, this is minus 39. If we just want to complete the graph nicely. But remember from T1, if that would be T1, maybe let's move the origin here to this side. And if we say this is T1, right, and of course here this is going to be T13. And this is going to be minus 3. So already anything below T1 does not exist, right? So we're not going to consider anything from there. But the less than 0 this time is... No. Actually, guys, we can't say less than 0. Remember, we divided by negative. This sign should change here. The sign should change. Oh, see, inequalities will catch us if we are careless. We divided throughout by negative, so that sign changes, okay? So it's not going to be this origin anymore, but it's going to be this origin. Ne? That's the one. So that's the one. So essentially we can write here that therefore n must be greater than 13. N must be greater than 13. Because when we give 13, it's going to be exactly equal to minus 110. We can check it out. We've got minus 2 into, we can say 13 minus 5 all squared plus 18. We get exactly minus 110. So when we put, say, 14, so we've got minus 2 into 14 minus 5 all squared plus 18. This gives us minus 144. Can you see minus 144 is less than minus 13? Sorry, minus 110. So this is good. This is good. And here, because remember this inequality is going to suggest even real numbers. We need to state this time that n is an element of all natural numbers. Otherwise, this answer is not correct without the domain being specified. Do you see what I mean when I say get into the groove of essentially get into the mood of stating everything? You see, let there be no further questions asked on you as to what you mean with your answers. Let your answers be overly explicit if they have to, so that no further questions can be asked, so that nobody can misunderstand your intentions. Right. And as you can see, that kind of approach becomes key here, because this answer would be incorrect without this, because this alone is suggesting all real numbers also after 13, and that's not the case. So these are some of the critical areas in solving these problems, folks. Right, so let's have a look here. Technically, the substitution, factorization, answer, but this time the domain is mark-worthy, right? The sketch, perhaps, yeah. So we have 5 marks. Where's the other one? Where is the other one? Maybe because there's a sign change, although this is not an algebra thing. But yeah, who cares? We can say, okay, all right, just to make up the 6 marks. But you can see you've got to consider a lot more. You've got to consider a lot more. All right. This is otherwise an easy 21 marks in this question. So this was more of a class work. I suppose though that the last question is truly a higher grade question that simply says we need to know what we are doing. And we cannot include the n values less than -3 because it does not exist. Why? The domain. So that rejection, you can write it straight up or you can write it the way I have. But remember, any inequality where natural numbers are involved and the variable in question is of the natural number set, we need to specify. Okay? If not specified, do what? Dead, and buried. Thank you very much. Let's get to functions. Okay, let me write nicely, man. Just for the vibes. Question 4. Yes. So here we need to consider the function f with a. What do we notice here? A is greater than 0 because that's the coefficient of the power. Power being the entire little thingy. You see the power is this whole thing. Please, it's not the exponent, but now I'm going to focus on the base rather than the exponent. So we can see that the base b is greater than 1. So when we have this combination of a greater than 0 and b greater than 1, this is suggesting that our function is an increasing function, number 1, that appears above the horizontal asymptote. Now, where is the asymptote? It's going to be this, because it's literally shifting the y-axis. It's supposed to be 0, meaning the x-axis, but because of what we call that vertical shift, so the whole thing has changed around. Okay, so please guys, be in the habit of doing these things. I beg you. It will profit you greatly in your next exam. But if this is not something that already exists in your mind, kuzoba nzima. So this is -6. Now, question is, our graph is increasing and appears above the horizontal asymptote. So it's doing stuff like this. Okay, so that's the stuff. Is it possible, therefore, for this function to have, say, for example, a positive y-intercept and a negative x-intercept? No. Why? Because we know that this moved from 0 to -6, so it means the y-intercept has to be between 0 and -6. So, yep, that's just the idea over there. So technically, essentially, I don't know, guys, if it is ever possible to do otherwise, but I don't think so. My understanding is that if we shifted the axis from 0 to minus, the y-intercept will always be between 0 and that number there. And if we shift it above the x-axis, the y-intercept is always going to be between that number, whichever it is, and 0. So if this number is negative, the y-intercept is going to be negative. If this number is positive, the y-intercept is going to be positive. But again, the shape of the graph is also key, meaning the shape of the graph is given by that piece. We need to also keep that in mind. I may be making unchecked inferences here, But these are things I challenge you guys to do, because I know most of you just practice. You solve for x, you solve for the y and x-intercept. You don't think about what seems to be the issue here. Because remember, as you study things, folks, sit back. At the end of your exercise, you will do it the standard way for sure. But sit back and ask yourself, what am I noticing here? Because after solving, say, questions on exponential functions, maybe 3 or 4 of them, there must be something you're noting that is not in your book, not in your study guide, but something very obvious like this. So would you know where the y-intercept is? Would you know where the x-intercept is by just looking at the expression that represents the function? Is there a way of doing this? Could you switch it around and see if different conditions would give a different opinion, or it will always be, faithful to your observation or so? So technically, essentially, sit and open your eyes. Now, because of the shape, we cannot have both negative unless we are shifting these x's. You see, if these x-axis, if they are shifting, we will see x having another value next to it. If then we shift the x-axis, that is the only time we can have a different scenario. So these are some of the things you need to sit back and notice. Don't be like a baby who needs to be told how to look at things all the time. Sometimes in the future, I won't be there. Someone else who also you listen to may not be there. Are you then suggesting that you're going to get stuck? No. You need not to get stuck, but you need to be able to solve the problems. So please, folks, don't be a waste of our effort. If you are listening and watching, please take these points seriously. You will see how this will simplify life. Of course, guys, life is hard for everybody. Whether you are smart, whether you're not, whether you're rich, whether you're poor, whether you belong to a particular racial group or you don't, or a particular ethnic group within a particular race or not, it does not matter. Life will always be hard when it gets hard. But it can also be very nice when it gets nice, and it does so for everybody. The way we appreciate it is the same. Forget about these influences of TV, magazines, social media lately, people pretending to live a life that they don't actually live and leading others to believe that's the way of life. At the end of the day, guys, if you have not noticed, any fake life always comes crashing down. At the end of the day, whoever you thought was the person, all of a sudden, in some years in the future, is no longer that person. And this is always true. It's never a lie. But those who actually live that kind of a life, comfortably so, you will see, even with the test of time, they will still remain relevant in that sense or in that light. And you will see why they stay there. They work hard. They get things done. They don't just expect things to just happen. And unfortunately, the so-called soft life is one that is suggesting that you don't wake up in the morning, go to work and work hard. It suggests the fact that you just sit back and enjoy life. No. Laziness will never give you anything meaningful, but you may do some wrong things and have that little piece of the pie. But remember, it's just a piece of the pie, because sooner or later it's going to be a burden, a heavy burden on your back. So what I'm trying to say, folks, please work your ground. Even if it's a small little yard at home, I'm making an analogy of that now. Please plant some veggies there, things that can be grown there, before you can fantasize about having a whole field, acres and acres, to then do the same job, if not more. But you cannot be hoping for more when you can't even use the little that you have. This is to say, when you study, folks, those things are measured, easy to handle, but study those things so that when you get a situation that is now much bigger and more challenging, you don't find yourself wondering, how am I going to begin? What am I going to do? As you can see, folks, the structure is very clear. You can predict it. Now let's put some meat in there. X-intercepts y must be 0. So that gives us 6 divided by 3. That's a 2. 2 to the 1. It means x is 1. Can you see? Our prediction was not wrong. So the x-intercept is 1. Now y-intercept means x is 0. So this is 1. 3 minus 6 is minus 3. Can you see? We didn't lie. We got it. We got it. So these are things you need to know how to do, even when not invited. Okay, so 4.1. We've got f is 3 times 2 to the exponent x minus 6. So let's answer 4.1.1 says calculate the x coordinate, the coordinates of the y-intercept. Okay, we know that for y-intercept, it is such that f of 0 is going to be equal to 3 times 2 to the 0 minus 6. We can say this implies that f of 0 is minus 3. Therefore, the y-intercept is going to be 0 and minus 3. Remember the question said coordinates. Yes, it's 1 mark, but for the pair, you're not going to get the mark here. It said coordinates, not y coordinate, okay? Be very mindful of the question. Second one says the coordinates of the x-intercept, okay? For x-intercept, it is such that f of x is equal to 0. This implies that 3 times 2 to the x minus 6 is equal to 0. We know that we get 2 to the x is going to be equal to 3. This is going to be 6, not 3, but 2. Because it's going to be transposing 6, dividing by 3. That gives us a 2, but we write it in a power form. So therefore, x should be 1. Therefore, the x-intercept is going to be 1 and 0. Right. So obviously, folks, perhaps that statement and the final answer is key. That's it. So we already worked them out carelessly, and it became the question. So we knew we are doing very well. So 4.1.2 says sketch the graph of f in the answer book. Clearly show all asymptotes and intercepts at the axis. So we already sorted that. So we'll just do the graph now. Nice. Okay, so origin, we're gonna say this is minus 6. All right, so there's our graph. It does stuff like this. Okay, not bad. So we know that the y-intercept is at minus 3. We know that this is at 1. And of course, that's f. Is there anything No, there's nothing more. So 3 marks is the shape, any one of the intercepts, x or y, and the asymptote. Okay, all right, okay. So we have 4.1.3. Hey, what is this now? See, again, guys, guard against this mistake I just made, because you will end up losing marks again over just the silliness that comes with, careless labeling. Right, so be very careful. It says now write down the range. So we know the range here, we can just say y must be greater than -6, where y is an element of all real numbers. Of course, the inequality itself is good enough, The element story does not really matter at this point, because we know that the inequality on its own, here x is unlimited unless restricted by that asymptote. This is why this is just 1 mark. This is just additional material, but please consider it. As you can see, in a different scenario, it becomes important. So you need to know when and when not to do something. So let's do 4.2. So 4.2 says S is -2 and 0. Already that's an x-intercept, because every time you see a y coordinate of 0 for any given point, that becomes an x-intercept. Okay, are the x-intercepts of the graph of, parabola, the standard form, and r is the y-intercept. Okay, if this is the y-intercept, it's suggesting that 0 is to some y value. Right. So it says now the straight line through r and t represents the graph of g of x equals -2x plus d. So it means this y here is also d. Okay. Maybe we can just clean it up and say, okay, this means this is d instead. Okay. Yep. So again, guys, these are very easy questions. We don't have to worry. It says find the value of d. Interesting. But we can see that this is a common x-intercept. So we know that g, this is 4.2.1. We know that g of x is equal to -2x plus d. Through that point t with 6 and 0, we know that 0 is -2 into 6 plus d. Therefore d, this is going to be -12 transposed, it's a 12. Again, classwork kind of a question. 2 marks, substitution and answer. So 4.2.2. Determine the equation of f in the standard format. Okay, not a problem. We know that f of x is basically a into x minus the first root into x minus the second root. Because when it is in the root form, this is what we do. So we know that f of x is a into x. Now let's see, the first root is -2, so it's going to be +2 into x minus 6. Now through this point r, which we get 0 and 12, it will be such that 12 is equal to a into 0 plus 2 into 0 minus 6. Therefore a is, so this is -12. 12 divided by -12 is -1. Of course, a should be a negative value because it's a grumpy face parabola. You can say then f of x is going to be minus 1 into x plus 2 into x minus 6. So this is going to be minus 1 into, we're going to get x squared minus 6x plus 2x is going to be minus 4x. Then this is minus 12. We can say therefore f is basically minus x squared plus 4x plus 12. So the y-intercept is somewhat suggesting the story, and a negative coefficient there is also suggesting something for us. So we may want to accept this. And again, we can see that b being positive and a negative tells us our axis of symmetry is to the right of the y-axis or the origin. So in a way, we should be happy. Again, to prove that this is the case, one can solve by factorization. This is going to be 6 and 2, right? 6 and 2, and of course another one is going to carry a negative sign because of the negative x. So we will still have the same x-intercepts. So in a way, we are convinced that we did this right. Of course, this way of writing is key. Substituting a point, the a value, and then giving the equation in the required format should be those marks there. 4.2.3 says if f of x is minus, can you see this is to confirm that we've got it right. Calculate the coordinates of the turning point, k of f. This is easy. You see, the problem here, many students may not realize, is that this statement, although not highlighted, dictates how this point should be given. Now, what is not allowed is to write this in turning point form, right? That is not allowed. Cannot write this in turning point form and then just write the answer. We need to see a calculation. So there are many ways we do a calculation. We see a formula, substitutions, and then answer, okay? That's the typical way we do this. So we need to show something like that. So we know that, well, the x is equal to minus b over 2a. This implies that x is going to be minus into 4 divided by 2 into minus 1. Therefore, x is going to be basically 2. Okay? We can say also f of 2 is going to be minus into 2 squared plus 4 into 2 plus 12, which means f of 2 is equal to, now this is 4, this is minus 4 plus 8, that's 4, 12 plus 4, that's 16. You can say therefore the turning point is going to be given by 2 and 16. I can accept this. It's not too much of a big deal, but let's check and be sure. So we have minus into 2 squared plus 4 into 2. As I have seen, okay, this is 16. I have seen that I made mistakes. So again, guys, here this is good, that is good, but please, if the question said coordinates, present the final answer in the ordered pair. The rest is your problem. This, unfortunately, required a calculation. So it's not a question that says determine, in which case you can do whatever you want. So if you show up with the vertex form without showing us how you got it, and then the answer, then you're in trouble. But if you show the vertex form, you need to show us the process of how you calculate it. Let me just show what I'm suggesting. One could easily do this and say, well, f of x is equal to minus x squared plus 12. And then work it out and say this is going to be minus into x squared minus 4x minus 12. And then this is minus into, we can show the calculation this time. And it's going to be x squared plus 4x plus half of 4. We divide that by 2, we then square it. And then, why do I have a plus here? It should be negative, okay? And then we write our constant term and we immediately subtract what we did. Okay? And that should be squared. Okay? Then we continue, we get minus into, we get x minus, we take that, it's going to be 2 all squared. And then we will have, this is going to be 2 squared, that's 4. 12 minus 4 is, again, my 12 is wrong. Should be negative. So minus 12 minus 4 is going to be minus 16. We can say this is now minus into x minus 2 all squared plus 16. Only then we can say therefore the turning point is going to be 2 and 16. But we need to show all of this. We need to show these calculations. We cannot just write this and then jump to that and then write the answer. That's not how the question said calculate. So you have options. You can do completing the square, then deduce the answer. At least there has been a calculation that we can see. Right. Right. It's as simple as that, guys. Yeah. Yeah. Okay, guys, I was just showing this. Maybe let's remove it to see if we cannot finish this question here. So we have 4.2.4. Now the question says, for which values of k will f of x equal to k have two distinct roots? Now we know that this is the same as y is equal to k and f of x simultaneously. Now this is a horizontal line, which means it can be a line through the turning point, maybe. Or it could be anywhere. Now, we need to think about these positions that I'm looking at. This is through the y-intercept. Okay. This could be... come on. This could be through any other part of the graph. Or anywhere else, okay? So if we look at this, this is an intercept. So there's two intercepts, which means roots. These are not the same. Here we only have one root, or we can say equal roots, okay? Here we have a situation. This is one root. This is also a root. 0 can still be a root in this case. So we can simply say, okay, all right, what is the value at the turning point? This is 2 and 16. So it means the y value, because all of these guys represent the line y equals k. It's a horizontal line. These are all the possibilities. As you can see, this is not correct because it gives us equal roots. There's only one point of intersection. But this one is good because it gives us two distinct roots, as well as that, as well as that. So we can easily say, well, k here must be less than 16. Nice and easy. So if k is less than 16, again, any other real value less than 16. So this is good. We get our 2 marks. Again, another student may want to do the nature of roots technique. Let's just demonstrate it for fun. So one can say we've got minus x squared plus 4x plus 12 is equal to k, minus x squared plus 4x plus 12 minus k equal to 0. And then we can say here, for unequal roots, it is such that b squared minus 4ac must be a greater than 0. Now b squared is 4 squared minus 4 into minus 1. Did I just write 4a here? This is 4ac. Okay. Now c is a complex number like that, greater than 0, and then we see that this is going to be 16. This is basically 4 times 12, which is 48. Then we've got 4 times minus k, which is going to be minus 4k greater than 0. And then 48 plus 16 is what? 64, right? Yeah. 48 plus 16 is 64. So we end up with 64 minus 4k greater than 0. Transpose 4k greater than minus 64. We therefore divide. When we divide by negative, the sign changes. 64 divided by 4 is 16. And you see, again, the algebraic technique is good, but the 2 marks is already suggesting that an answer only is key here. So looking at the graph sometimes is what gives a quicker answer than. But again, nobody said how. If the instruction is not suggesting that use the graph to determine, then you can do the algebraic thing. Perhaps you can do it on the rough work and then take the answer as the answer only. Or you can do it within the same thing, because even for 2 marks, guys, there's nothing wrong with doing this. Because we know for sure that we know that even with this technique, technically, what would get a mark is the substitutions and the answer. So there's nothing wrong with following the entire thing, okay? But of course we need space. I'm not going to waste this space. Just wanted to show that you're not limited to just one way of looking at these things, but master both techniques so that if it is dictated that one particular technique or method is to be used, then you can do that, okay? For example, one can say calculate the value of k so that this equation is like that. Maybe say calculate the values of k such that f of x is equal to k has two distinct roots. Do you see that? A question that says calculate, you cannot just use the graph like I have for that answer, meaning an answer only is not going to be accepted. We need to see a calculation. But if someone says determine, we can either calculate or use the graph. But if somebody says use the graph, then we should not see any silly calculations that are outside the graph for sure. So remember those things. There are many ways in which we can ask the same question, and there's different ways in which we can ask this particular question will determine if you are going to get full marks or not, because it is instruction based. Now determine the maximum value of h of x equals 3 to the exponent f of x minus 12. Of course, for this to be a maximum, it means we need the maximum of f, because that's all that is variable here. The rest is what it is. So we can say h of x equals 3 to the exponent f of x minus 12. We can say this implies that maximum value of h is going to be equal to 3 to the maximum of f is 16 minus 12, which means therefore the maximum value of h is, now 16 minus 12 is 4, 3 to the exponent 4 is 81. So this would be the maximum value. So again here, determine, we can do it by calculation or whatever means any student wants, okay? So in essence, that's it. We've just used the graph and some calculation, which is the easiest, because we just look at f. What is the maximum of f? Is 16. Then we take the 12 and we move on. Nice and easy, guys. So basically this substitution here and of course the general substitution and the final answer gives us 3 marks. This could have been easily 2 marks. The third mark is truly a bonus mark, okay? So we can see that we can walk away with these 20 marks effortlessly if the work is understood and known, okay? So far so good. Let's move on to the next question. Question 5. Now here, the graph of f is minus the square root of 27x for x values greater than 0. Of course, this is to suggest that we can't have a negative under the square root sign, because that would not make any sense. But again, this is a parabola. If you look at it, it's an inverse of a parabola. Okay, so it's sketched below. Point P with coordinates 3 and minus 9 lies on the graph, so that's good. Easy stuff. So use your graph to determine, use your graph to determine the values of x for which f of x is greater than minus 9. So this means we do not expect calculations here, essentially. So if we look at this graph, when is f of x greater than, it's all these values from here. So if we do this, say, okay, this 3, we trace it back. Not quite. Better. So we see that this is 3 and this is 9. Minus 9. So for which x values are the y values less than minus 9? Sorry, yeah, greater than minus 9. It's all these ones right here. See all these x values here. And including 0, because 0 is greater than minus 9. So all those values are literally the situation. So we have here 5.1. We know that x should be less than or equal to, because it is included, 3, but should be greater than and equal to 0. Right. Again, the inequality itself suggests real numbers between and including those values. So this is good enough. For 2 marks using the graph, you can answer only. So you are not allowed, folks, to do this algebraically, but you can if you want, but be very careful. If you chose the algebraic technique, you can write here f of x is greater than minus 9. This is minus the square root of 27x greater than and equal to minus 9. Multiply throughout by negative, we get square root. In fact, we can just forget about that. We can square both sides. So when we square this, we get 27x is greater than, squaring doesn't change the inequality. This is 81. And then we divide x is greater than, yeah, there's a catch. This is x, what is this? X, 27 divided by 81 is 3. So can you see that technique, my lord? It just didn't go so well, hey? So it already suggests that for us to really thrive here, at least to get 1 mark instead of 0, because this one is misleading. That one is misleading. I didn't think it was going to mislead us so bad. This one just misled us badly. Okay, I think the way we can get close to the right answer here is to first divide. So minus root 27x greater than or what? We can divide by negative. So we get square root 27x less than or equal to 9. And then we can square. We can then say x, we can say here 27x is less than or equal to 81. Therefore, we can see that x is going to be less than, maybe let's not do this therefore part yet. So x must be less than 3, right? But remember, the domain was already given, so we need to include that. So we can say, therefore, x must be less than 3, greater than or equal to 0, as it was volunteered. See, that part came from the original domain. Right, because when x is less than 3, we need to keep in mind that x was never supposed to be less than 0. Right, so this could be another way one can do it algebraically. As you can see, there's finesse to this. You can't just say, I cannot mind the negative. This time you truly have to isolate the radical so that it's positive. If not, we got a wrong answer. So, but part of me feels like squaring both sides, even when we did not deal with the radical, it is suggesting something, we need to think as to how indeed will that sign change, because it's supposed to change, it seems. But I cannot explain it, because as I said, squaring does not necessarily change the sign, but perhaps for the structure that we have, something is fishy there. Anyway, folks, this is just to expand and stretch your knowledge, to show you how to work things out. Of course, you would do this in the rough work and just write an answer, because if you start showing a calculation, remember everything is wrong, because the instruction said use the graph, meaning rather don't show a calculation. If you did one, do it in your rough work and then transfer. But again, if this appears in the rough work and we see the answer, but again, you could justify yourself by saying, look, I was just checking and confirming if my answer is correct. So they cannot have a leg to stand on. If you did not highlight rough work to be marked, they cannot. Even if you did the wrong thing in the rough work, that was not required. But you just go back and plug the correct answer. Even though they can see it, they are not at liberty to mark you wrong. Why? Because if you were to be called as to saying, what were you doing here, student? You could easily say, look, I was just confirming if my answer is correct or not. And that was it. So what are they going to say? Nothing. Height. Yo, guys, nilambile. 5.2. Says, write down the equation of the inverse, okay, of f in that form and include all restrictions. Right, so we can say, look, this is 3 marks, so there's a lot of things, and this is saying write down. This means an answer only, but with some extras, okay? So the inverse, of course, we swap x and y first and foremost, so we can work it out. Say, okay, we can have minus. By the way, we can just have x is equal to minus the square root of 27y. Ne? Yeah. And what we're going to do, we just square both sides now. So we get x squared is equal to 27y. We then solve for y. It's going to be x squared over 27. Right, so this is it. So we can just write y is equal to 1 over 27. 1 over 27 x squared. But remember, with the inverse, we were told x must be greater than 0, right? Right, so what happens here now? We know and fully understand that in this case, I'm thinking, guys, this one is a dangerous question, is it not? Because we know the restriction on the inverse. Let's say the restriction is on the domain for the original. For the inverse, the restriction is going to be on the range of that graph. So here we are going to have to restrict y, because x can take any value essentially. X can take any value, but Y cannot in the inverse. And of course, this one, ebafethu anisiyeke ngalesilungu ebafethu lithenga le question izongiqhela kabi. Why izongiqhela? Yabona wengijijile ngoku because khona into engenzi sense at all up. Yeah, but I think a problem is the same as what we did above, I think the problem is the same as what we were trying to do above. People are questioning. There was a question that we tried to do something about. In fact, 5.1, you see, it's the same thing as 5.1 because now this is suggesting that this is not quite legal unless we know how to justify things, because you see, this doesn't really capture the restrictions very well. You see now, because if we look at this is x is equal to minus the square root of 27y. Ideally, this we should divide by negative so that we have minus x is equal to the square root of 27y. I got a gafana, man. In my mind, I thought the square root is going to come here. No, it does not. Kuyafana. Noba senza ntoni sithola njengalandlela. Oh, okay. Hayi kazinipopene ke manje angisazi. So bhala iphi restriction because it just said write down. Okay. But all I know is that the inverse here, guys, is going to be doing things like that here. The inverse is going to be doing stuff like that. Why? Because this point gives me the guide. This is why I'm conflicted in what I want to say. We swap the x and the y values. When we do so, that point P is going to be P prime. The mirror image is going to be minus 9 and 3. Can you see that? That point was the key to this. Otherwise, it could very well go wrong. It could very well go wrong. So what does this suggest, guys? Well, this suggests that Tell the question man in Chichilendoni. Yeah, but this one is going to suggest, guys, that the restriction here is such that x is less than or equal to 0 because we're not going to have any x value that is positive on the other one. Okay? I don't know, guys, what else is there. Is there anything more? Because in any case, even if we were to show the other half, it would go stuff like that, So all the y values are positive, whether we like it or not. So I don't know if it is necessary to include, but I think what was the turning point here, or the key step, was to appreciate the fact that in the inverse function, we swap the x and the y coordinates. And if that's the case, it puts it in the second quadrant. So I think this would be it, guys. Maybe 2 marks for this. And then for that, Just a moment. Let me check something. I'm hungry. I must chow quickly. Just an apple. Yes. Oh, this apple is nice. Besingilambe kakhulu guys. Ayenzosweleka, okay? I think this is it. But now I'm thinking of something else also though. That if we're looking at the range of this function, it's y less than 0. But now the range of the inverse is y greater than 0. So I think that would be the third restriction maybe, or maybe the second restriction, and say maybe, I'm not sure, y must be greater than or equal to 0. Perhaps that would be the extra restriction. I'm not too sure though about this one. So please check the official memo and find out, or consult your teachers perhaps, who would know better. As much as I can do this, I have limitations too, because I don't read, these materials religiously anymore. Sometimes it's just a matter of I know what to do and I just jump in. And at times it can be quite limiting, you see. Because I don't get to review this. The idea is to review this before one presents this work, making sure everything is, proper, but I don't have that time. So where I fall short, please guys, fill in the gaps, okay? Now it says sketch the graph of the inverse and indicate the intercepts or intercept with the axis and the coordinates of one other point. Okay, we already did it somewhat. So we're gonna do it again. Just transcribe what we saw. And there is our graph. So of course, the intercept is going to be the origin, and that other point we can call it P prime, which is going to be -9 and 3. And of course we indicate this is the inverse function. So it's simple. Again, folks, we normally get a point, shape, any one of the intercepts and that point. Nice. So 5.4 says describe the transformation of f to g if g of x is equal to the positive square root of 27. So it means we multiplied the entire function of f by negative, and when we do that, that's a vertical reflection. So we can say, well, g is the graph, or maybe we can say is f reflected about the x-axis, right? Because that's a vertical reflection, or we can just say it is a vertical reflection. And so g is a vertical reflection of f, or g is f reflected vertically or reflected about the x-axis. The key here is on the x-axis, and that being a reflection. So this is easy. So again, guys, this was a rather easy 9 marks if one knows what to do. Except my confusion for 5.2, I'm a bit shaky there. Anyway, I was thinking things that were incorrect, so I suppose what we did is correct, okay? Right, so let's do question 6. So question 6 says, the graph of a hyperbola with equation y equals f of x has the following properties. The domain is an element of real numbers except 5. Right, so that would be our vertical asymptote. The range is an element of real numbers except 1. Again, that's our horizontal asymptote. It passes through this point. Then we need to find the equation. Again, guys, this exam was purely classwork, yo. Evan, what is going on here? Okay, so we know that basically f of x here is equal to a, which we don't know. Now we're going to say x. Now this time, if this is equal to, is not to be 5, then it means it must be minus. So we take the opposite sign. But this one, we put it as it is. If y is showing up positive there, then it should be positive. And then we say through this point, 2 and 0, it is such that 0 is equal to a over 2 minus 5 plus 1. So this implies that we transpose minus 1 over 1 is equal to minus 3a. Wait, it's going to be minus a, or maybe let's just leave it like that. It's going to be a over minus 3. Then we cross multiply here. We don't really need to show this thing. Therefore, our a is going to be positive 3. So we can say then f of x is going to be 3 divided by x minus 5 plus 1. Right, so that's the best we can do. Now to prove that this is true, we can take this point and prove that the left-hand side is equal to the right-hand side. So if we look there, the left-hand side becomes 0. We put a 2 there, it becomes minus 3 divided by, it becomes 3 divided by minus 3. That's minus 1. Minus 1 plus 1 is 0. So 0 is equal to 0, to suggest that that point is truly a point on this particular graph. Yes, we may have made a crime elsewhere. It's possible. But the fact that our equation balances what we have, we can be sure that most likely everything is correct. So technically, writing our equation like this is key, substituting is key, getting our a value is key, and rewriting the equation because that is what we needed to find. Again, this is more of a classwork type of an exam. I have no idea what was going on here. The students were made to just write classwork in the finals. Yo, aibo. Baziyekela bangatholi distinctions la. Hi guys. I have not really seen a tough question here. One that makes me spin my head a bit. But again, it doesn't have to be like that anyway. At times there has to be rewards for going through school. Because yeah, at the end of the day, it's a standard exam, is it not? Okay, a business buys a machine that costs 120,000. The value of the machine depreciates at 9% per annum according to the diminishing balance method. Okay, this is the reducing balance method. Okay, so we know. It says now determine the scrap value of the machine at the end of 5 years. So this is easy. So we've got 7.1, 7.1.1. We know that A is equal to P into 1 minus I to the exponent n. The present value is 120,000 into 1 minus 9% is basically 0.09, all to the exponent 5. So A is going to be money. So let's see, this is 120,000 into 1 minus 0.09, all to the 5. So this is 74,883 rands 86 cents. Remember, money is to 2 decimal places only. Yes, we can do 1 if we want, but we cannot do more than 2 for money. Now remember, this is unfortunately very specific. Now my question would be, what happens when the question says round off to 1 decimal place? Well, it's possible. When it says to no decimal place, it's possible. But when the general instructions said 3 decimal places, which is unlikely, it's either we say minimum of 2 decimal places or we say maximum in the general instructions. It's all because for issues like money, we cannot do less than or more than 2 decimal places. Okay, maybe we can do less than, but we cannot do more than 2 decimal places, right? Right. Otherwise, that money will not make sense. Right. So, that's it. That's it, guys. But it's mainly going to be 2 decimal places. Again, it's not a big question. Nope. No. Substitution. Answer. 3 marks for what? Come on, guys. Maybe for the exponent or this, I don't know. Anyway, any one of those 2, but I mean, this is a 2-mark question, guys. Stop this. Stop it now. So we've got 7.1.2. Okay, it says after 5 years, the machine needs to be replaced. During this time, inflation remained constant at 7% per annum. Determine the cost of the new machine at the end of the 5 years. Again, same story. It's just compound interest this time. A is equal to P into 1 plus I to the n. This implies that A is equal to 120,000 into 1 plus, this time it's going to be 0.07 because that's 7%, to the exponent 5. So it means A, this is money, so we must write the right units. So this is 120 squared into 1 plus 0.07 all to the exponent 5. So this gives us money of 168,306 rands 21 cents to 2 decimal places. Okay, so again, folks, substitution answer. I don't know why this is 3 marks, but for this one, I would perhaps say there were 2 little interest rates that we had to consider. So choosing the right one perhaps would be, would be the correct thing. So maybe 3 marks there is justified. So let's do 7.1.3. Says the business estimates that it will need 90,000 rands by the end of 5 years. Okay, a sinking fund for 90,000 rands into which equal monthly installments must be paid, is set up. The interest on this fund is 8.5% per annum, compounded monthly. The payment will be made immediately. The first payment is made immediately, and the last payment will be made at the end of the 5-year period. Can you see here? This is very clear. So now let's deal with our timeline. I always like to do this because it helps to put this into perspective. So T0, we already are putting some, some X-rays, and the last term, remember this is monthly, so this is going to be 5 times 12. This is going to be T60. So we are doing this as well, putting our X-rays, which is what we don't know. And of course, we were told that during this entire period, the interest is at 5% per annum compounded monthly. All right. Great. So it says calculate the value of the monthly payment. This is a future value calculation, so we know that F is equal to X into 1 plus I to the n minus 1, all divided by I. Again, you can check the formula sheet if you're not convinced. X is what we want. Sorry, our future value here is 90,000. Right? That's what we want. Equals X. So 1 plus, the interest is 8,05, so this is going to be 0,085. Is that so? Let me see. I'm feeling like, 8,5 divided by 100. Yeah, it's 0,085, and then we divide this by 12 because this is monthly. Now the exponent is n. Remember, how do we get the exponent? We take the last, we subtract the first, and we add 1. So 60 minus 0 is 60 plus 1 is 61. Okay, there's an extra payment here. So this is going to be 0,085 over 12. Right, the gymnastics that need to be performed, we make X the subject. This will cross multiply with that. So this is 90,000 times 0,085 over 12. All of this is going to be divided by the big bracket, which is 1 plus 0,085 over 12 to the exponent 61 minus 1. Therefore, X is what will be the result. So let's do it. 90 square into 0,085 divided by 12, all divided by 1 plus 0,085 divided by 12, all to the exponent 61 minus 1. It gives us 1,184 rands 68 cents. Okay, it's not bad. That's quite a reasonable amount for what we want to get. Okay guys, so this is the story of our lives. So a very simple calculation. The trick here was here. And all of this is given by the immediate payment and the payment at the last, or it didn't end the month before the end. You see things like that. So these are the things we need to consider. Of course, folks, we can simply say here substitutions. This is 5 marks, okay? Left and right, and perhaps getting the interest and getting the period and the final answer. That should be enough for 5 marks. The gymnastics are not really that big a deal here. Okay, let's do 7.2. 7.2 says Lorraine receives an amount of 900,000 upon her retirement. She invests this amount immediately in an interest rate of 10.5% per annum, compounded monthly. So this is again some future value thing, or just compound interest for that matter. She needs an amount of 18,000 per month to maintain her current lifestyle. Okay. She plans to withdraw the first amount at the end of the first month. For how many months will she be able to live from her investment? Okay. Of course, according to the lifestyle. Again, we want months, so that's not a problem. We always need our friend called the timeline. Find it easy to figure out what is going on. At T0, she is depositing 900 scodos. And she then, in the first month, she is taking away 18 scodo. And she continues to do this until the very last month, which we don't know what this is. Again, this should be when she is able to take 18 scodo out, okay? And of course, the interest on our investment is 10.5% per annum compounded monthly. Right, okay, cool. So this is just to suggest how many months will she be able to withdraw the 18 scodo. Right. Now, we know that we can use the future value calculation here and say future value here is basically x into 1 plus I to the exponent n minus 1 all over I. Right, so this implies now our future value is this amount plus interest. So this is going to be 900,000 with the compound interest of 1 plus 10,5, basically 0,105 over 12. Right. Now all to the exponent n. Okay, because this started accumulating interest such that we will take this, subtract that, and add 1. Okay. This is going to be equal to this monthly withdrawal into 1 plus 0,105 over 12 to the exponent n minus 1, all divided by 0,105 over 12. Okay, the key thing here was to notice that the future value is going to include a compound interest. And we can just figure out that we could easily say this particular amount must be made up of these installments over this same situation. You know. Yeah, so essentially, guys, what we need to do now, we cross multiply this there, and divide by 18 to free this bracket. So this implies this. Now when we take this value, we cross multiply it over there, it's going to multiply the 90,000 actually. So it's going to be the 900,000 times 0,105 divided by 12, okay? That's what we're going to get, and then we divide by this 18,000. It gives us a 7/16 into 1 plus 0,105 over 12 to the exponent n equals, this one frees this bracket of 1 plus 0,105 over 12 to the n minus 1. So that's the gymnastics. Again, guys, if you don't know your maths, unfortunately, you're not going to survive here. So we can see that this friend is a like term to that. So we can either take this to that side or take this to this side and take one to the other side. Either way, I think it's nicer to just take this to the other side. And from what we can see, we're going to have to factorize by taking this out. So what we end up with is just this bracket of 1 plus 0,105 over 12 to the exponent n into, this is going to leave the 7/16 minus 1, right, is equal to minus 1. Just to avoid making mistakes, sometimes just take it step by step because marks can be lost here. So essentially, we don't want this guy, so we end up with this 1 plus 0,105 over 12 to the n is equal to minus 1 divided by 7/16 minus 1. Now we introduce the logs. So we know that log, you know guys, step by step, if you jump steps for so many marks, at times critical steps are going to haunt you. So what we do on the left hand side, we must do on the right hand side. Okay, this is what we have. So we can say here, this also implies, now we want n. N is going to be the log. The base is going to be that 1 plus 0,105 over 12. The number is going to be minus 1 divided by 7/16 minus 1. Okay, so we can make a conclusion that n is going to be, remember, we said months when this person is going to be able to maintain this current lifestyle of hers. So it's going to be the whole number. That is before the decimal. So do not take anything after the decimal here, because we cannot leave 1.5 months, isn't it? We just said months. So we want months where we take 18 squared. So we've got log, our base is this complex situation, plus 0,105 divided by 12. Our number is complex, is minus 1 divided by 7/16 minus 1. Okay, you just punch it as I wrote it, and we move on. So it says 66,04. But remember, the 04 part, it's when she's not gonna, withdraw 18,000. But here, for us to say she actually lives on this investment, it's when she can get what she needed. So technically, N is going to be equal to 66 months. That's it, because that's what the question was about. Yes, the 67th month, she's not going to be able to withdraw 18,000. And of course, that's not necessarily going to give her the lifestyle that she has. So technically, we can ignore the other part. So be very careful on how to answer questions, folks. Listen, or rather read from the given statements. What is the implication? And of course, don't be lazy to perform some algebraic gymnastics here, where you show some of the important steps, because they may be the ones, because I mean, for 6 marks, marks can be anywhere. Of course, this is key. Using the logarithmic rule in a way, it's also key. Technically, when we factorize, you can think about it, it's key. We can say this left-hand substitution, the right-hand substitution, that's also key. So how many marks now? 1, 2, 3, 4, 5. We need the 6th. So where is the 6th mark? Maybe when we introduce logs here, and then use log rules. That could be where the marks are, because other steps are not that important. But as we know, 3-step factorization is important. So whenever we do stuff like that, it's key. Substitutions important. You name it. You see. Yeah. The other way one can think about it, one can think about this as the loan and these as repayments, calculating how many repayments of 18,000 if the loan was at this, rate, interest rate. So one can still use the future value formula, but I'm not going to do it. You do it yourselves. Sorry, the present value formula. This is going to be x into 1 minus 1 plus I to the minus n, all divided by I. Now for you there at home, please use the present value calculation. Of course, taking the 90 score as the present value, right? And the 18,000. So from our timeline, we're going to take this as our present value. And we're going to take the 18,000 as our repayments. And of course, take this as a question that says, how many 18,000 rands payments will have to be paid by this person to pay off this loan? It's going to be 66 of them, in a way. Use this and see what you get. If it's not the same answer, then you have done something wrong. And now this technically, guys, is a question that is similar to what came out in May, June 2025. Not 2005. 2025. Okay? So those of you who worked through these problems, as I highlighted, that sometimes look at what was the case back then work slowly towards what has been recently, because you don't want to be caught out. I can tell you 60% of the questions are going to come from the recent question papers, the way they were asked. Then the 20% may come from questions from way, way, way back. Of course, they're not going to be necessarily repeated, but they will be the same kind of questions. And then the other 20% can just be a mixture of whatever the examiners are thinking about. that you should be in a position to do. Of course, this is an arbitrary distribution of how questions are asked. It's just me, guessing. But again, not guessing ignorantly, but with some understanding in there. All right, so try the present value and see if you're not going to get the same answer. As I said, if you did not, then you did something wrong. But if you did, then you did it all correct. So this could be some easy 17 marks here. Of course, if you understand what to do for the last question, because I would say the last question is really one of those questions that force you to think as a student, because these are not standard textbook questions usually. So these are truly the exam. All right, let's get to question 8, guys. I'm taking forever here. We're doing differential calculus. Now this is the easy part. 8.1, we need to find the first derivative from the first principles of our f of x function. We know that f prime x is the limit as h tends to 0 of f of x plus h minus f of x, all divided by h. So this implies that f prime x is the limit as h tends to 0. We substitute. So this is now going to be 2. Where we see x, we put x plus h squared with minus 5. We subtract the entire expression of f of x. Okay, that's it. So this implies that our f prime x is going to be the limit as h tends to 0. We expand all of this. So this is going to be x squared. We times that by 2 is going to be 2x squared. The next one is going to be 2xh. Then we multiply that by 2 is going to be plus 4xh. This is going to be h squared. Then times 2 is going to be plus 2h squared. And we say minus 5, and then we distribute. This is minus 2x squared plus 5 over h. And of course, when this happens, you know you are on the right track. So again, step by step, folks, no jumping anything. F prime x is the limit as h tends to 0 of 4xh or hx, whatever, plus 2h squared divided by h. And then we know that we want h out of the denominator, because it makes our expression undefined. So we take h as the common factor. Here we remain with 4x plus 2h divided by h. Now this finally frees us to do the things that we want to do. But remember, step by step, students. No jumping the gun. F of x is going to be the limit as h tends to 0 of 4x plus 2h, which also implies that f prime x is going to be 4x. We drop the limit plus 2, we then substitute with 0. Therefore, f prime of x is basically 4x. Again, using the power rule, the student would have known that this is going to be just 4x. This is 0. So in a way, this is what would have been the case, which would lead us to just 4x. Okay, so this is fairly easy. No questions about it. It's just that we needed to uncover this using the first principles. Of course, guys, substitutions into the correct formula, important. And the expansions and what, well, we can think about it, but I think factorization is usually very important. Dropping the limit when we put a 0 there is good. The answer is exactly what we want. So the fifth mark perhaps comes from whatever happens when we expand and solve. All right, not a big deal. Very easy. So 8.2. We need to find dy dx. If this is the case, again, that expression is ready for issues. So we can write it back again and say y is x to the minus 4 plus 2x cubed minus x over 5. We can say therefore dy over dx will be minus 4x to the minus 5, right? Plus 6x squared minus basically x to the, no, there's not going to be an x, minus a fifth. Done. Okay. Very good. Very nice. So this one is easy for each one of these derivatives. Is very easy. 3 marks. Okay, 8.3 is quite busy, so we can write it here. 8.3, we are given g of x equals x squared plus x minus 2 all divided by x minus 1. Okay, so let's now find the first derivative provided x is not 1. Why? Because it would be undefined. So we have 8.3.1. We know that the first derivative, okay, it's not ready for differentiation, by the way. G of x is gonna be, let's put it again. I don't know why I'm copying everything all again. But you see, guys, some things need to follow. So this implies that g is, we can factorize this numerator divided by x minus 1. So this is going to be x. This should be plus 2 minus 1. Now that factor takes care of that factor in the denominator. We can say therefore g of x is essentially x plus 2. We can say therefore the first derivative is basically going to be 1. Nice and easy. You see. The 2 marks, folks, is the factorization and simplification and the answer. Well, one can also think of the other mark coming straight from what g turns out to be. This should be a 3-mark question, to be honest. Factorizations and giving g and then the answer. Okay, so 8.3.2 says, explain why it is not possible to determine g prime of minus 1. I mean, g prime is a constant, so it cannot be anything. So we can just say g prime of x is a constant. And so it will not be possible to determine G prime of 1 is there is no variable x. Of course, it can be any other variable in the expression. Of course, guys, say as much as you can. You know, sometimes you're not prepared for a crazy question, but as you can see, if g prime of x is just 1, a constant, we cannot, because it means the gradient is the same value. Because this is a straight line equation, by the way. So the gradients don't change. So no matter where we do it, it's the same gradient. Right. So that's it, guys. Again, for 1 mark, but say as much as you can. But I think the anchor to this answer is that this is a constant, so it cannot be changed by anything else. And it's not possible to find it elsewhere. Right. Easy 11 marks. Differential calculus, guys, is a piece of cake. Just slice it and chow it. Okay, never flinch here. If you do, then you're careless. Carelessness equals punishment. Punishment means disgraced. And if you are disgraced, you are going to be, not taken seriously. Not taken seriously means whatever it means. It means you are insignificant, unfortunately. All right. And if you are insignificant, it means we can discard you. Yay, when just too bastard. Anyway, question 9 says the graph of the function f of x equals minus x cubed plus da 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 da. It's given in full. All we know is that the y-intercept is at 16. The rest we're going to have to figure out. It's sketched below. So it says calculate the x coordinates. See, x coordinates of the turning point. Okay. Right. Please, guys, take care to copy this correctly. Don't be lazy. So 9.1.1. We know that at the turning points, it is such that f prime x is equal to 0. This implies that we do the differentiation minus 3x squared minus 2x plus 16 should be 0. This also implies we can try and factorize this thing. If we can't, we use the quadratic formula. So I'm going to have minus 3x and x. Then 16 is 8 and 2. Right? So if I put 2 here and put 8 here, I'm good. Because 3 by 2 is 6. The difference between 8 and 6 thereof is going to be 2. So I want this to be positive. I want this to be negative. Sorry. Again, both of them are negative because the last term is positive. Nice and easy. We can say therefore x is basically 8. No? It's going to be minus 8 over 3. Or x is 2. And we can see there that that turning point is giving us the vibes. So we see that this is minus 4,5 basically. No, 8 over 3 is something else. Right, and this one, yeah, guys, this is good. We are happy. So question was on the x coordinates, so we did it. So of course, guys, this statement is good, the actual differentiation and the individual values. Nice and easy. 9.1.2 says calculate the x-coordinate of the point at which the f prime x is a maximum. Now we know that this is the x-coordinate of the point of inflection. So we can just say, well, we can say f prime x maximum is such that the second derivative should be equal to 0. So when we do this differentiation, we differentiate that first derivative. So this is minus 6x minus 2 is equal to 0. Therefore, x is going to be minus a third. Right. Okay, there are many ways one can use the other formula. X is equal to minus b over 2a, on the second derivative function here. So one can use that for this business. Still, you'll come up with a negative a third. Right, so this means our graph, perhaps if we say this is minus a third over there, so this is saying that would be the point of inflection. Another student may have thought of it that basically x is going to be the average of these two, so which is basically minus 8 over 3 plus 2, all of that divided by 2. Let's see, minus 8 over 3 plus 2, all divided by 2 still gives us minus a third. Okay, so that's an option. One can trust the the x-coordinates of the turning point and know that the point of inflection is literally the average of those two x-coordinates of the turning points. And that's it. Or you can use differential calculus. Whichever method, guys, it's good. So this statement is good. The actual differentiation, the answer. And if one chose this method, one would get a mark for this, that sum, and perhaps whatever. Yeah, it doesn't matter. It matters not what you do, but what you do must give us the answer. Okay, let's do 9.2. 9.2 says consider the graph. Okay, this is a parabola. G of x is minus 2x squared minus 9x plus 5. Okay, 9.2.1, we can see this is a grumpy face parabola. It says determine the equation of the tangent to the graph at that point. Okay, so we know first of all that we want g of minus 1. Perhaps we can say the point of tangency. Which I call the port, is such that g of minus 1 is equal to minus 2 into minus 1 squared minus 9 into minus 1 plus 5. This is going to be equal to, now this is 1 times minus 2, that's minus 2. Minus 2 plus 9, that's 7. 7 plus 5 is 12. can say therefore the port, we can safely say this is -1:12. We needed that. Again, just do it on the calculator, guys, at times. But again, don't overly rely on the calculator. Do give your brain a chance to think, so that when what you have done on the calculator doesn't make sense, you can see it. Don't just trust the calculator. We can say, well, what do we know? We know that also the gradient of the tangent is equal to the first derivative at -1. So this implies that the gradient of our tangent, now the first derivative here is going to be -4. Instead of putting this, we're going to put -1 here. Okay, and then this is just going to be -9. Therefore, the gradient of a tangent is, so this is going to be 4 minus, this is 4 minus 9, which is -5. Okay, right. All right. Okay, I'm thinking about it now. What is this case here? This parabola is like this. Yeah, this one will have unequal roots. Oh, by the way, let's see, where's the axis of symmetry? This is negative, it's going to come up positive, but because of this, it's going to be negative. So this is stuff like this, maybe. All right, so always think about what I just said, guys. It's very important. Now we can see that definitely at -1, if this is what we think -1 is, we can see that a tangent at that point is carrying a negative gradient. So we can accept this answer, you know. All right, we can say then the tangent is such that y is equal to -5x plus c through the port, which is -1 and 12. 12 is -5 into -1 plus c. Therefore, c here, as you can see, the tangent is carrying a positive, it's going to have a positive y-intercept. So this is 5 when you transpose, gives us 7. Therefore, y is -5x plus 7. So we can accept. Right, so this is not bad. It's very good. So basically, guys, we needed the point of tangency. Can give a mark there or maybe a mark here. Doing the first derivative and getting the gradient, that's another mark. And of course, getting the equation. Wow, this is crazy. This is not fair. This should be 5 marks. But again, we've done enough substitutions. We've done them twice, so whatever. I only gave, we have 4 marks. It's fine. So 9.2.2 says, for which values of q will this line not intersect? Now obviously same gradient, you know, same gradient as our graph. We can clearly see that for this not to touch, it must be a line that is perhaps same elevation but perhaps much higher. So it means this Q should be greater than 7. But now for 3 marks, this is already spelling out trouble that you cannot just give an answer only, because an answer only here is going to say Q must be greater than 7. So for this, we cannot get 3 marks. So this is another way an examiner is forcing us a different path, okay? So the easiest path here for me is to just say, well, we know that we are just suggesting that this equation here, minus 2x squared minus 9x plus 5 is equal to minus 5x plus q, must not have real roots. Okay, maybe we can say that. Okay, we can say has no real roots. This is what this means. So we can say for, okay. We can say this implies that we've got minus 2x squared minus, when we bring in the 5, it's going to give us minus 4x. Then we're going to have plus 5 minus q equal to 0. We can say for non-real roots, it is such that b squared minus 4ac must be less than 0. This implies that minus 4 squared minus 4 into minus 2 into 5 minus q should be less than 0, which implies that 16, this is going to be 8 times 5, this is plus 40. And then minus, this is going to be 8 times this is going to be minus 8q, should be less than 0. This implies that minus 8q should be less than, this is 60. No, this is 50, 56. But minus 56. Therefore, q is going to change around when we divide by negative, and 56 divided by 8 is 7, right? So this is basically the impression that we need to show a calculation here, because we cannot earn 3 marks for an answer only like that. As much as we can, we will not. Right. So that's the way, guys, to solve this problem. I think a calculation is necessary. But what about a graphical method? Obviously, if one would choose a graphical method, I would perhaps suggest that you need to draw the graph, show this line, and show the tangent, the new equation like that. Then write the answer. The sketch needs to be present, I suppose, but I mean, it's cumbersome. You're just doing the same thing more than once. But again, yeah, that's another way. But I think algebraic technique here is not bad. But as I said, you can just take that sketch, guys, bunch it somewhere, and then write the answer. At least the sketch and the answer would give us 2 marks, because it shows that you used a graph, because nobody said what to use. If it says for which is as good as saying determine, yeah, I'm actually more convinced that we can say here, all we can do, we can just take this dude here, say, okay, come here. We copy, and then we move down here. We paste our friend. And of course, we make sure we show those lines like that. You know. Maybe let's paste this one too. Damn it, man. Damn it, man. Hi, boo. We want to put this one there to show that it was the initial tangent, to show that these, in fact, you may even show more that these have parallel lines, or they are parallel. You know. And from here, you can make a conclusion that therefore Q must be greater than 7, because we know that this other line cut at 7. Right. So I would suppose this would be 2 marks, and the sketch is 2 marks, and the conclusion is 1 mark, whatever, guys. So there are many ways of doing maths, as long as we do it. As long as it is done. I do think, yeah, it's a valid option to just draw a graph, you know, to show what we are dealing with. Of course, these graphs would need to be labeled. So this one is G, right? And then that was the tangent. And then this is the line. You can just write line, you know. Simple and straightforward. Simple and straightforward. That's if you choose the graph. So you can use any means necessary. But I would prefer this one because this is key, writing this in standard form. The discriminant, the answer, in fact, more of the substitutions, and the answer. That's 3 marks. Okay, all right, okay, guys, so we're doing fine. I'm a bit tired now. 9.3 says, given h of x is equal to 4x cubed plus 5x. It says, explain if it is possible to draw a tangent on the graph of h that has a negative gradient. And again, it says, show all your calculations. Keyword, we must show calculations. Okay? Is it possible? Okay, let's find out. What I would do, I would literally try and draw the graph, but remember, I need to show calculations. I can say here x-intercept as such that h of x is equal to 0, which implies that 4x cubed. In fact, why do I waste my time? We don't have time here. As such that 4x cubed plus 5x is 0. We take x, this is 4x squared plus 5 equal to 0. We can see that x should be 0 because this has no solutions. The discriminant is negative. Right, or you can decide if you transpose 5 and divide by 4, you see a perfect square cannot be equal to a negative number, right? Or we can take a square root to solve for x there. So It's only 0. So the x-intercept is 0. Zero and 0. Right, and the y-intercept, we also see that also it is not, because there's nothing here. So there's no constant, so it means also the y-intercept is going to be 0 and 0. This is obvious. Obvious. And then we can say turning points are such that h prime x is 0. So this is basically 12x squared plus 5 is equal to 0, which again has no solutions. So this means there's no turning points here. I don't know, guys. For 3 marks, so much work. Well, whatever. When this is the case, guys, we already know that the x-intercept must be also the point of inflection, right? You can say point of inflection is also such that the second derivative of h is 0. This is basically differentiating that expression that we got, which is going to be 24x is equal to 0. Therefore, our x is not. For now, this is the x coordinate of the point of inflection. Now we can see that, okay guys, if we take 0 into the original, we get the same thing. So the point of inflection is literally 0 and 0. So we can say therefore the boy is 0 and 0. Now from here, guys, I can draw the graph. No one tells you what you need to do. Just do what you can do, because some questions are silly and there's nothing you can do. And of course, we will see that x, y, that, okay? Now, this graph, what do we notice? The a value is positive. So this is a graph like this. But now, it's doing other things. So it's going to do stuff like so. And it's doing stuff like this. You know? Or what I can do is to copy this, paste, take it there, done. So that's the graph. That's what we get, okay? So this is h. As we can see, guys, if we draw tangent lines here, they are all positive. So this graph has no negative gradients. So this means any tangent, again a local tangent, will not have negative gradients, because at the points of intersection or points of tangency, the gradient of the function is equal to the gradient of, you know, the tangent. We can say since h has only positive gradients, there will be no tangent with a negative gradient. All right, so that's it from me. I've done what I could. So basically, guys, for just 3 marks, okay, of course, our conclusion matters. We can say all these calculations because we were asked to show the calculations, all of them, 1 mark. And to show the sketch, this is what gave us the impression that the gradients are positive. In fact, we know that this is also a gradient function. And we can see that for all x values, that is always positive. So that could also give an indication. So this makes me think we can actually take this alone and say, well, the first derivative is always positive for all values of x. Therefore, the gradient will not have functions, because if we look at this graph here, it's going to be a graph like this. Since this is positive, it's going to be concave up. Oops, my battery is dying. And then, of course, the constant is also going to be the y-intercept. So this is something like this. Okay? So essentially, I can see now I did not need to do all these other calculations. But again, guys, you never know what you need sometimes. You just do what you can. Okay? Okay. Just do what you can, because you never know what you will need. So this means for 3 marks, actually the first derivative function can answer this nicely without sweating. Okay. So this is the one. This is the one. Okay. You see what misled me is calculations, because the first derivative function, we don't really show all the calculations, do we? But maybe we should. Yeah. I'm thinking now we could easily say, oh, we take h of x as is given, 4x cubed plus 5x. We can say implies that the first derivative function is going to be 12x squared. Maybe it's 12x. But again, if it says show all your calculations, it forces us to say this is going to be 3 times 4 x cubed minus 1. This is ridiculous though. So this is going to be 1 times 5, and then x to the 1 minus 1. Therefore, h prime of x is basically 12 x squared plus 5. Ne? Which is always positive for all real values of x. Therefore, no tangent with negative gradient is possible, you know. Okay, no such a tangent. Okay, I think one can use this as an option, seeing what came out, because yeah, the other calculations are a little bit outrageous. Yeah. So one can do that, but again, there's no harm in what we did, guys. That just means for all the calculations you get 0. Sorry, you get 1. Maybe for the sketch you get 1. Maybe the sketch may be necessary, may not, but I think whatever method you've used, that's it, guys. Of course, for this one, the marks would be to show the calculations, to get the first derivative and the conclusion of everything. Okay, yeah, I think so. But again, guys, it's at your discretion which method makes any sense. Again, this could be an easy 17 marks, but I do think the last question is somewhat a higher grade question in its construct, but not really what can I say? Not really impossible to do. All right, let's move on to question 10. Question 10 says, a particle moves along a straight line. The distance s in meters of the particle from a fixed point on the line at time t seconds, which is t is equal to and greater than 0, is given by this graph. Okay. Again, what does that graph represent? A parabola. That would look stuff like, okay, we can factorize all we want. Maybe we might win, we may not win. I don't care at this point. But fact of the matter is probably something like so. Okay. Yeah. So always imagine. Oh, by the way, we've got t this time. T, and here this represents the displacement in terms of s. This is s at t. Okay, right, or we can just say s, because s represents the distance. It's not a big deal after all. So that's the graph we have, guys. Nice. Yeah. Because I know that the middle term, the reason I know there will be positive roots here, I know that this is negative while this is positive. So it means both my brackets have negative signs and the answers thereof are going to be positive. So be able to look at the sketch, guys. I mean the equation, and imagine what the sketch should look like, even if you don't have the actual values, but have a representative sketch so that whatever you do becomes easy on you. It says calculate the particle's initial velocity. Remember, velocity is a rate of change of displacement. So that would be the first derivative function here. Okay, as the rate of, say, what? The initial velocity, okay. Now we basically want the gradient of this graph when t is equal to 0. Because that's the beginning here, right? So basically we want, the question is saying we need s prime of t, sorry, s prime of 0, ne? S prime of 0. That's what the question is. Can you see that? Yeah. So we can just say, well, s prime of t is equal to, we differentiate, it's going to be 4t squared minus 18. We can say therefore s prime of 0, the initial time, it's going to be 4t, which is 0 all squared minus 18. Maybe not. Conclusion. Therefore, s prime of 0 is going to be minus 18. Now, question is, this minus 18 is just telling us the direction of motion or maybe the gradients thereof. But remember, the question is initial velocity. At this point, nobody told us what direction this is. So our job is to say, therefore, initial. Remember, we write what is right. Initial velocity is going to be equal to 18. We ignore the answer. 18 meters per second. Now, the question is here, is the velocity increasing here or decreasing here? Well, we know by looking at the model here, the gradients are decreasing up until we get to the turning point. So if we draw tangent lines, we know that the gradient initially is much steeper, but the negative value tells us that it's decreasing. So it's decreasing, 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 up until it's flat, right? For this time frame, we can easily say the negative value means decreasing. Or we can say the initial velocity here is 18 meters per second, decreasing, I guess. Yeah. Yeah. It's decreasing, decreasing. But in maths, do we really care about the direction? Well, it's not a physics exam, but, well, knowing physics is important. But remember, guys, answer the question. We used a mathematical model, but the question still remains the question, initial velocity. Nobody asked you an S prime of 0. Yes, this is the implication, but we need to answer the question. So if you end with your S prime of 0 equal to minus 18, you get nothing for the answer. It's a means to an end. It's actually used as a means to an end. It's not an end in itself. So let's be mindful of what we do, making sure that we display proper understanding. So obviously, guys, to take the first derivative is good. To substitute 0 is good. And to give the answer, remember the answer must have the unit of measurement. If it does not, dead. The explanation of decreasing or increasing at this point, it's just you trying to show that actually the velocity started high and it's slowly decreasing up until the very minimum velocity it could reach. And then it can start accelerating in the opposite direction, so to speak. So this is a car that is slowing down, that stops momentarily, then turns back in the opposite direction. You get it? Yes, yes, and yes. You see, physics can be looked at mathematically. Right. Those first 3 marks are in the bag as complex. You see, now this is a true exam question because it makes you think a bit. Determine the rate at which the velocity of the particle is changing at t seconds. Okay. Well, this is again looking for the s double prime of t, because this is just to look for the second derivative function, and obviously that is going to be a constant, right? We know it. So we can just say, okay, s double prime of t is going to be basically 8t. So now we can say the rate at which velocity is changing at t seconds. What is at t seconds? I'm a bit lost. I think I made a mistake. This is not squared. That's why I'm ending up where I don't want. So this is here. I made a mistake. It can't be squared. It has to be just 4t, right? Right. So again, guys, be very careful of what you write. See, easy to make lousy mistakes that don't necessarily change the answer, but they can mess up everything. See, that wrong thing there would literally lose you those 2 marks. You would only get 1 mark for the answer. And you lose the next mark because of the wrong notation there. That misleads us. So we know that this is just 4. We can say therefore, remember the question was on the acceleration. We can say therefore the rate. We can even write the rate of change of velocity is equal to 4 meters. Remember now, this is meters per second squared, because this is acceleration. If you like, you may just write the acceleration is equal to 4 meters. This is now deceleration, because remember, okay. Well, it decelerated from and started accelerating at, okay, maybe at this point we can leave this one alone because it came out positive straight up. It didn't say much. So the acceleration is like this. Ka, kwaba. Ka, kwaba. Ka, kwaba. Kwaba, 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 kwaba. And what do we know here? This tells us the gradient of the first derivative function, right? Which is 4. So that is how steep it will be. Ne? And anyway, guys, yo. Yeah, this one is crazy, but it's fine. So this one is the answer, guys. This one is the answer, okay? So you could do it by inspection from the first derivative function. You know that the coefficient of the variable there would be what remains. So writing this as an answer only without showing us what is cooking is okay. But showing us what is cooking is not bad, because as we often say, a question that says determine, it's an open-ended question. You can approach it whichever way you choose. Okay, not bad. 10.3 says, after how many seconds will the particle be closest to the fixed point? Again, this is an issue of maximum and minimum. Okay, again, when we say closest, it can be farthest or closest. Closest is the minimum, because we see that this is the question about that point. We just want this part, the x value or the t value at the turning point. So we can say, well, we can just say s prime of t should be equal to 0 to answer this question. Then what do? We say 4t minus 18 should be 0. This implies that t is going to be, maybe let's be systematic a bit. You can say therefore t should be 2 to 18 goes 9 times, to 4 goes 2 times. We can say seconds. At least this one is after how many seconds, so we can just see that this is qual. So this statement is key in the answer. And remember, guys, if you write that answer as a decimal, it's going to be 4,50 seconds. I always feel uncomfortable writing the seconds like that, but yeah, can we can. So what I'm trying to say, don't forget the extra digit if you chose decimals. Or else, yes, yes, yes. Easy 6 marks, guys, if you understand. But again, this was a nice exam question because one has to understand things. But again, I just probably did too much. This is very simple. Again, this could also qualify as a class test maybe, rather than an exam in the national, the final exam. Final exam, guys, should be a killer, like a true killer, because it sifts those who understood and those who did not. Alright, guys, lumi apil. Okay, masgqibe ndizovele nditye once. Now, most of you guys do not do linear programming for grade 12. But again, it was a grade 11 thingy for us. So I want it back, guys. This is very useful. It should come back. However they may choose to bring it back, it has to. It just has to. Maybe we can have extra 30 minutes for this to be done as well. Maybe an exam should be 3 hours and a half, because I think linear programming is also necessary. It's very necessary. So yeah, again, in algebra, instead of doing too much quadratics there, we either solve by using the quadratic formula or we do by factorization, but the next question should be on absolute values. I feel it should be. Very important, those things as well. Then we can say our paper 1 is nicely balanced, honestly speaking. There has to be. I am advocating for this. Add linear programming and add absolute values. Now we can find a way. There's lots of questions that we are probably repeating ourselves. For example, yeah, but I think functions are okay to be kept the way they are. Sequences and series are also okay to be kept the way they are, but yeah, we can add extra questions for 1 point. Maybe we can have 1.4 as the last question standard. Then we say 1.3 can be anything. We can add above some extra questions on the algebra. Then maybe consider adding extra 30 minutes overall, Then this would be a proper paper 1. Because I don't like the paper 1 the way it is. It's not complete. But again, we also didn't write it complete because we didn't have probabilities. This is why it dribbles me a lot. I don't have experience of it, but I understood how to use it when we were doing genetics in my third year. So doing probabilities, we did it there. Although we didn't really fully understand the fundamentals, but we understood how to use it. So yeah, most things happen. Okay, let's get to this question 11. It says a calculator company manufactures 2 kinds of calculators. A scientific calculator like mine and a basic calculator. Sasisithi amagwinya le bala amagwinya. Omama babethengisa amagwinya babebala ngayo le capkisayo ne asevenkileni. Okay, the company is able to sell all the calculators that it produces. Okay, cool. A system of constraints has been developed for the production of the calculators. Cool. The feasible region is shaded below. Now the question is, do we see any shading? The answer is no. We just see feasible region here, but we don't know what is the extent of this. So again, guys, sometimes I don't understand things here. I hate exam question papers like this. This is, again, saying things about the ones who are supposed to ensure that the question papers before distribution, guys, represent exactly what is stated. But now we don't know where is the feasible region for sure. We can't. There's A, B, P, what. We don't know which part. Is it this? Is it this? We don't know. Is it is it this whole thing? We don't know. We see A, B, C, and D. Is it this? We don't know. You see? That's what I have a problem with. But again, it's an exam, guys. We need to exercise our logic here. So let X and Y respectively represent the number of scientific and basic calculators produced each day. All right. Okay, all right, okay. So now, guys, when we cannot identify much, we then have to skim and scan the questions. Because from the questions, we will gain an understanding of what is what here, okay? So, is it possible for the company to manufacture 15 scientific calculators and 5 basic calculators in one day, according to their system of constraints? Motivate your answer. Okay, let's just look at where this point is. 15 scientific and 5 basic. So this, at least, is suggesting that this point is here. Now, our main challenge is the fact that we don't know what is the feasible region. If this was the feasible region, we could accept it, because anything in the feasible region, as you hear the word feasible, so it's an area of possibilities. So, well, not knowing where the feasible region is, we can't answer that question. But we will then, once we identify enough information to pinpoint exactly where the feasible region is, we can answer. So the first question we can't answer for now. It says, write down all the algebraic inequalities which describe the constraints related to the manufacturing of the calculators. Again, these algebraic inequalities are the boundaries of our feasible region. So we don't know at this point where it is exactly. We cannot answer that question as yet. The profit Q in hundreds of rands, okay, very important. If we ever have to calculate the profit, we then times by hundreds of rands, meaning if we get 5, it's a 500 rands. If we get a 6, it's a 600 rands. You know? Right. So this profit is given by Q equals X plus 3Y. So meaning we take one of the scientific and then 3 times those of the basic calculators. Okay, this is key. And of course, this Q here represents, this Q represents the profit. Okay, cool. Says now, the dotted line on the graph is a search line associated with the profit function. Again, do we see a dotted line here? No. So where the hell is the dotted line? You see? Hi guys, it says too much ngoking like that. Where is the search line here? On the graph, okay, associated with the profit function. Cool. We don't know anything here. Okay, but we see a P that is perhaps different from a we see a P that looks different from the other labels. You see the others are nice, same color, but this one is bold. So could it be something like that? And P lies on this line. Could this be the line that is spoken about? We don't know, but we may think so. Again, there's clues, but we are not yet sure. Okay, So fine. It says now 11.3.1. Identify the point in the region where the profit is maximum. Of course, the region is the feasible region. Where the profit is maximum. Use only A, B, C, or D. Now, can you see they are literally giving us now what actually defines the feasible region, meaning is that area surrounded by those letters, because those are the vertices of the feasible region. Okay, so now there is our feasible region clearly defined. And this should have been shaded in the first place so that we could answer those questions. But again, examiners do this deliberately at times so that we can see that, okay, all right, okay, we have what we have. Now, guys, usually inequalities that represent these constraints do not necessarily cause through the feasible region. They never do. So we can safely say this is probably the search line. This is probably the search line. And that P, now we can accept that is probably trying to say the same thing. But anyway, let's try to zoom into this and see what happens. So if we look here, of course, you won't have this luxury in the exam, guys, unless you would have what we call a magnifying glass, which we used to use, but I think for physics. I don't know if it was given for, a math exam, but yeah, a magnifying glass, which was possible to have as a student. You could see that the way these lines look, for example, look at that line and compare it to this one. Can you see that line is of the same way as that? It's like a thread, same way as these ones. So we can easily say, okay, those are of the same order, but this one is a solid line, slightly different. But if you look at this one, it looks almost dashed, so to speak. So this could be the dotted line that they were talking about, But again, folks, in the exam, you don't have this luxury of zooming in, unless you would have a magnifying glass, which I doubt is necessary for a math exam, okay? So ayibafethu ngelinye ixesha ezinye izinto zenza sense. It just shows that the coordination process is not followed properly. Kodwa ke ndisengaba ndiyabhuda nam, only to find that the key was for one to do this, because this 11.3.1 is actually key to answering all these questions. This could be just the way the examiners are hiding this. And of course, if you did linear programming, you would know that the set of constraints that define the feasible region are normally not the line that will cause through the feasible region, but they would border the feasible region because it is bordered by those lines. In fact, let me not say it would. It is always bordered by the set of constraints. They form the borders, they don't cause through the feasible region. Anything that would show up causing through the feasible region is very likely to be a search line for the maximum profit. So now we can see that, okay, from there we can go on and answer the questions above because we know what is what. Again, guys, you can just skim and scan and say, write down the coordinates of a point on the dotted line. Can you see on the dotted line? If the point exists at which the profit is greater than the profit at P, can you see? That's already suggesting that the dotted line was supposed to be that line. Again, this is another giveaway. Through skimming and scanning, right? Now, given that the profit, when given by Q equals AX plus BY, now this is hypothetical, where A is greater than 0 and B is greater than 0 also, is a maximum at B. Okay? So we're assuming into point B. Determine the maximum value of A over B. Okay. Okay, it's either we can find the value of A and the value of B and then do the fraction or whatever. So again, this is one of those questions we'll get to once we reach them. And usually these are higher grade questions where now obviously your understanding is important. And you can see that this question, guys, it's actually a simple concept, you know, the concept of linear programming, but you see the examiners switched it around and made it a bit silly. I could be wrong by crying that this is bad though, to talk about a dotted line that we don't see and to talk of a feasible region that is not clearly defined. It was bad, but I guess the secret must have been 11.3.1. All right, let's get to these questions quickly. 11.1, can we see now this point lies outside the feasible region, so it cannot be. It is outside. It's not defined by any of the constraints, we can say. So we can say no, it is not. No. Because that point, we can say the point 15 is to 5 lies outside the feasible region defined by the set of constraints given. Okay, we can be all English, you know, guns blazing, showing us that you have learned this language. Tina, we don't care about this language. We just speak what we can speak. And if you can hear us, you know, most. But yeah, key is that this is outside the feasible region, folks. That's why it is not possible. Because anything outside the feasible region, it means it's not part and parcel of this business. We'll just be missing out. Anything within that feasible region, yes, is possible. Because these constraints are telling us that anything in that region we can do. Okay? Either we maximize or minimize or we stay okay, whatever it is. That feasible region is the safe zone for our business model to be constructed, meaning we can produce 25 scientific calculators and 10, you know, basic calculators. That would put us in a good light, you know. Anyhow, this is the one, guys, just 1 mark for no and the explanation. Can you see a very easy question could not be answered because of how crazy the answers, the information was given. It says now write down all the algebraic inequalities which describe the constraints related to the manufacturing of this. And as we know, guys, what we see is these are solid lines that define the feasible region. If at all one of them was a dotted line, it means it's not included, that line. So we always shade like this. That means if we shade it that way, it's greater than and equal to 20 because the line through A and D is a vertical line. And it means we shade it underneath that line. So that line here, you see that line, it means we shade it below. So it means it's either on the line or below the line. Again, less than and equal to. And we look at this line. Again, if we look at this line, it means we shade it below that line. So it means it's less than and equal to because it's a solid line. And of course, don't forget the x-axis, we shaded above them. So it means, again, we don't see dotted lines there. So it means it's solid, it's included. So it's equal to or greater than. So that's how we construct these. So we can write first, taking that border there, it means x must be greater than or equal to 20. Then taking this horizontal line, it means y must also be greater than or equal to 0. right, because that is the mark 0. It's a horizontal line through the origin. And now this one comes and hits us. So what I'd like to write these ones like linear equations. So we get y. Now we saw that this one is less than or equal to. Now the gradient for this line is going to be y divided by x. So 25 divided by 50 is a half x. Now the y-intercept is, as you see it, it's 25. Okay. Or another student may decide to just multiply the y there, then we get x, and then we get 50 here. So at the same time, you can easily say this 50 comes from there, and then we say this divided by that, it gives us the 2, which we multiply to y, and x remains. Okay, I don't know, many ways of looking at this, but I'd like to write this as a set of, linear inequalities. Now let's have a look at the last one. This is the steep one. Again, the gradient is going to be change of y over change in x. So 40 divided by 40 is 1. So we just write x plus 40 because that's the y-intercept. Again, guys, you can do whatever you want, but get the equations right. Get the equations right. Is there more? Of course, the search line, we don't include it because it's not bordering. We only include those that border our feasible region. So this is 1 mark. Maybe we can say 2 marks for these ones because they're a bit complex. Total 6 marks. 11.3. Now we have that story that the profit Q in hundreds of rands given by, okay, the dotted line. Now we have identified what that should be on the graph is a search line associated with the profit function. Okay. It says now, identify the point in the region where the profit is a maximum. Now, obviously, guys, we take the search line. How we do this, let me give it a different color, blue maybe. We take the search line, right? Of course, you would use a ruler here. Take the search line and move it up. Remember now, when we maximize or minimize, we cannot enter. You see, this one would be a minimum. But this search line must be at a point so that it does not enter into the feasible region. It must not cross. We want the borders, a vertex thereof. Now, we cannot do that because that's the smallest value we can have. We cannot do anything at C, whether minimum or maximum, because it enters into the feasible region. B, we cannot do it there because it also enters the feasible region. But at A, yes, of course, we might do something there. So it means we can maximize at A. So it means this is going to be 11.3.1. That's just A. Nice and easy. So 11.3.2. Can we get 1 mark there? Now this one says, okay, write down the coordinates of a point on the dotted line, which is the search line, if the point exists, of course, at which the profit is greater than the profit at P. Now let's look at the profit at P following this equation. This is 30 plus 5 times 3, that's 15, which is 45. Let's look at C. This is basically, no. At that point, it's 45. So it's 0 and 45. So this is 45. Let's look at this point where 15 is. So this is 15 plus 10 times 3, that's 30, that's 45. So it's always 45 at that point. This is 15 by 3, that's 45 when this is 0. So it means the profit is always 45 along that line. So we can say the point does not exist. The profit is always 45, or is is the same as at P throughout the search line. Okay, just show guys that you get it. Okay, so basically here we can say the point does not exist, because we need to justify why. Although it didn't say justify this, but for 2 marks, you cannot just say no, does not exist, and that's it. But maybe it's possible. I mean, it's not quite a weak disagreement, whether we know the reason or not, but I would spread the no as 1 mark and some justification. Right, easy. Now let's get to the big boy, or is it the big girl? So 11.3.3. Given the profit, now this is the hypothetical situation. We're told A is greater than 0 and B is greater than 0. Is a maximum at B. Now if we maximize at B, it means our search line, must be not entering our feasible region. It must be something like that. Okay, so at point B, our search line must have a gradient basically like that, because it must not enter. So this is to suggest we are changing things now. The original search line is different now. We're saying any search line, if at all we want to maximize at B. So what are we suggesting? We will see that technically that would be the gradient, which is between this line and this line. So which one is the biggest? Of course, the more negative is the smallest, the less negative is the biggest. So it means the gradient of this yellow line must fall between the gradient of this line and the gradient of that line. Of course, here you can see it's 4 marks. We can't just write the answer, so we need to work things out. So we can say, well, Q is given by AX plus BY. If we make y the subject, because this is a linear equation, we know that y is going to be minus a over b times x plus q over b. Now we can clearly see that a over b is a gradient. And we needed to show this for our 4 marks. And now we can see that, well, if we maximize at b, this is the constraint that we need to satisfy, such that the gradient of our profit line must be between the gradient of this constraint over here and the gradient of that constraint. Of course, we start from small to big. We can say this implies, maybe let's do this. This implies that a over b, in fact, we can say minus a over b, because first of all, we look at it literally, must be less than and equal to, because this line could easily be, the very same line as this line, because at b it gives us a maximum. Could also be the same as that line, or anything in between. So it's going to be less than or equal to the gradient. The biggest is the least steep one. This one came out as a half. It's minus a half from above. But this should be greater than and equal to that one. The big value here is the smallest. Is the smallest gradient, yeah? But now remember, we're looking for a positive answer, because this is written positive. So when we multiply by negative, we will see that a over b, or maybe let's show. We can say we multiply by minus 1 here. This becomes positive. A over b. Now this sign changes to greater than, right? This means this one is greater than that, but now the sign changes. It means this one is going to be less than that. So this one is going to be less than and equal to, and then the one becomes positive. This one changes. Now it's less than, this one's going to be greater than and equal to. That half becomes positive. Okay. Now remember, we want the maximum value. So if this is the range of values, which one is the biggest? It's 1. So it means the maximum should be along this line. It means our search line should be along this line. Right. And so the maximum, can say therefore A over B should be equal to basically 1. Right, so that is the answer there, guys, because that would be the maximum. That is the minimum, maximum. So can you see, guys, this one was a tricky one. Yo, I'm feeling dizzy by it. And guys, the network, the electricity, apparently there was some fixing that was going on throughout the week. So I saw that the power is a bit stable today. So I don't know if you guys want. Actually, by the time you see this video, anyway, it will already be irrelevant. So we'll just continue our classes on Monday. Let's just do that. Let me just have this weekend to myself. Do my things, and then we meet again on Monday. Of course, guys, from Monday we are going to sprint until month end. Okay, we are sprinting until month end because some of you are going to be sitting for your trial exams, so we need to really revise and make sure everything is on point. Okay, so Monday I will get my what we call power banks for my modem, and that is for the Wi-Fi, and for my tablets and phone. I'm gonna go to the hospital if the power is unstable and charge it so that we don't get interruptions, unless of course the entire networks just don't work well in general. Okay, so that's it, guys. So we know that we're gonna get 1 mark for this, maybe for making Y the subject, because we needed to understand and picking out what minus A over B should be according to the graphs that we were given. That's 3 marks. Multiplying by negative to get this, that would be the 4th mark. And of course we get our lovely 11 marks, which were not quite easy to think about, but knowing the strategy to deal with problems even when you have a problem. Yeah, sometimes you may win, sometimes you may not win. At the end of the day, you just need to know what to do, guys. And once you know what to do, you'll always do it well. Remember the 3-step approach, boys and girls, ladies and gentlemen, mothers and daddies, granddaddies and grandmothers, malumes and malumekazis, that's uwamentanis, you name them that you can mention here, is the thing. Okay, guys, I hope you enjoyed the video. If you liked it, give it a thumbs up. If you didn't like it, still give it a thumbs up. Someone else might like it or might benefit from it. So yeah, don't be that guy, please, guys. Why do you tend this vimbi likes? God, why ni like into ezingenangqondo? Ividiyo ezingenangqondo apha ezipostwayo kule platform, dodi nje we-videos, you find that ividiyo ina 7,000 views, ibina 1.5 likes. Butenge guys, but ufika apha i-views zi-15,000, i-likes zi-85. Like, are you trying to tell me out of anyway, bafethu siniyeke ninjalo, ni-ignorant nina abantwana besikolo, ndiyadazi andiyiqondi into enenza. Abanye umuntu uthi wayebenefithile angalike. Like why? why undivimbi likes mfethu? By the way, awuvimbi mna, uvimba abanye abantwana, you know. And let me tell you guys, abanye abantwana abenibavimba as likes nizivimba nicimba nivimba mna andivimbeki apha because le into lena yi-hobby kum le bafethu. It's not a job, it's a hobby, to be honest. But again, I will not make it look like it's a mere hobby. It's my desire to give something back to students who are struggling, who might benefit from my way of doing things. But my way of doing things is not really unique, to be honest. It's just a variety of how things are done anyway, in general. It's just that it depends on the angle I may choose rather than the other angles that are possible, you know? So it's just my wish to give something to somebody, you know, who might benefit from it. But I don't really expect much from it personally. But my expectation is to see a change in others. And I have seen that change. Like I told you guys, the first student to have a class with me online is doing his study in medicine at the University of Pretoria. He approached me through my channel and asked to really contact me when they need to. I gave them my WhatsApp number. That's the first person to get my WhatsApp number, which is literally my phone number because that's the number I use. I don't have a separate phone. So, I mean, the intention for him at the time was mainly physics because he was struggling with MCQs. But when we drilled this, he started to realize that it's nothing. It's actually what he knows and knows best. And then we even stretched it to maths. The guy got his distinctions and he's a third-year medical student now. Next year is literally becoming a fourth year. He's almost done. He's joining me in the field very soon. So, I mean, that is those that I taught online. The first student to be taught online was that guy. So again, this channel made a difference, at least. It doesn't have to be the whole country, guys. Just one or two people, that's satisfactory for me. Because I know, akekho umuntu othandwa ngabantu bonke. In fact, the moment abantu abaninzi bekuthanda, uhle uyazi bakhona into erongo oyenzayo. Because abantu bayithanda into erongo ngobuninzi. Into right bayijaja. It's always like that. Okay, it's mostly like that. Let me not say it's always like, it's mostly like that. People often judge what is right because as it comes, it's commanding and it's demanding and it's not giving you any hiding places to sit with your ignorance or anything. It exposes your ignorance instead. So people don't really take to that. I'm not saying my channel is that good. No, I'm just saying in general. Of course, you will read between the lines if you can. But again, be very careful not to read between the lines when there's no lines at all. Actually, ndikhalazela nje le nto yoba guys, I don't understand. Video even at 20,000 views, even at 200 likes. Like, no. Unless, of course, people just check, oh well, boring, move on. Maybe that's the case because again, that's the only way it makes sense. But those who sit and watch, I'm sure they would not just go on without a like, you know. But this YouTube thing, again, it's a lie, guys. Sometimes the likes are not truly the likes anyway. We know it. Sometimes the subscriptions are not truly the subscriptions we see, you know. There's a whole lot that goes into the algorithm. Sometimes you are gifted numbers that you don't actually have. Because if a person, for example, watches a video and maybe is a frequent person to watch your videos, even if they didn't subscribe, the algorithm will just count them as subscribers. So at the end of the day, it's not quite true, man. And you will see, the moment those people fail to watch you regularly, you start to see your likes falling off. It's not, your subscriptions falling. It's not because they unsubscribed. People don't really have time for that, man. They just move on usually. Unless really they are mean people who would go to the extent of unsubscribing. Because, you just leave it like that. You just turn off the notifications. You will never see anything. Or you will hardly see anything. You know. Anyway, guys, I hope you liked the video. Forget about the complaining. I'm not necessarily complaining. I'm just pointing out the fact, which for me, it's a bit, I just learned a word that means confusing. Combobulating. Yeah, it's combobulating. Wow, what a word. I've never heard such a word, but I just came across a word. It says combobulating. Is that so? I think so. Yeah, it leaves me combobulated to see views not matched by likes, because in my opinion, if of course those views were true views, I doubt anyone would hate. They would like, right? 20,000 views should have 20,000 likes. But again, yeah, we know this is an algorithm, you see. Yeah, even if they liked, some likes are not counted for a strategy. Imagine how many people would want to be paid lots and lots. I mean, those would translate to some serious revenue, right? So where would YouTube get the money? So they have to manipulate it, or else they will lose. Anyway, guys, goodbye. We'll see you some other time. But for those who attend my classes on Monday, folks, we're up and running. I'll make it a point. This week caught me by surprise. I was hoping every day we're going to have a class, but right around 7, power goes. Exactly the time that we start our classes. So, but again, I'm also a full-time employee, guys. So, and my job is very demanding. I come back very tired. So at times I feel like, you know what, I cannot do this, guys. I need to nap nyana, vele ndizomeke ndilale. Yabo. So bese zimkile kanjalo. So ingxaki lapho ke guys, ngelinye ixesha ke it's not necessarily the power issue, but this week has been the power issue. But there are days where, ndizifika apha ndidiniwe, ndathi ndikhe ndithi kunqenqa kancinci ndiphungule nje ukudinwa, vele ndiya avuka ngo-11 ebusuku sendilambile, and andidli ngexesha eli-right because akho mntu ufanele utya ngo-11 ebusuku. Isapha or idina, whatever you call it, fanele ityiwe ngabo-6, but no later than 7. Kwenzela uba ngo-9 ukwazi ungena ezingubeni xa ungumntu ongenanto engenye fanele uyenze, so that ulale enough uzovuka ufresh ungelovila. Ngafika emsebenzini ukhamisa, ufika ukhalaze, eqonda. Yeah, anyway, guys, that's it for me, and I hope you guys have enjoyed the ride here, and I hope I was as clear as a white goat on a on a scorched field, okanye ibhokhwe ehlungwini kwabo basazi isiXhosa. Ndicinga njalo uba bendiclear kanjalo nam, andazi ke. Nizondixelela apho ndingakhange ndicace okwebhokhwe ehlungwini. Niphinde nindibuze apha ngoku ndicacile kodwa ndingakhange ndivakale kakuhle. Zikhona ezinye izinto othi ngoku uyibona kodwa ungayiqondi. Qomba ndiyambona yena lo mntu kodwa ndimqondisisi kakuhle. Then xa ufuna ukuqonda, khona phaa indawo yabantu abafuna ukuqonda, ndithi the comment section. Beka phaa imibono yakho, imibuzo yakho, izikhalazo zakho, kananjalo nokugxeka kubalulekile. Ngelinye ixesha funeka niyigxeke indlela endenza ngayo xa inengxaki, ngoba isengaba zezinye zezizathu zoba abantu bangakwazi ukuxhamla. Ibe le nto bebenokuxhamla kuyo, but ngenxa yendlela endenza ngayo mhlawumbi. Ibe nyhani ke okuyigxeka loo nto ungandenza ndiyilungise, mhlawumbe ithi kanti izawulungela wonke omnye umntu emva koko. So zinto ezinjalo ke guys. Bye-bye yini, ndibona xesha elizayo.